What's going on, guys? Welcome to the Swift Networking Masterclass, your gateway to mastering the art of networking in Swift. I'm Stefan, and I'm going to be your instructor throughout this amazing course. And believe it or not, I've been exactly where you are right now. Starting out as a self-taught programmer and eventually becoming a senior software engineer at Meta, I know exactly what it takes to succeed when you're teaching yourself these complicated concepts. So now I'm excited to share my knowledge and experience with you guys in this comprehensive masterclass to help you succeed. So I hope you guys are ready to demystify these complex networking concepts like dependency injections, unit testing, caching, and get ready to ace your technical interviews and build high quality iOS apps. If that's what you want to get out of this course, you've come to the right place. So in this course, we're going to cover everything from the absolute basics to the advanced techniques and architectures like dependency injections and caching and Swift concurrency, ensuring that you not only understand the fundamentals, but also have the skills to tackle complex networking challenges with confidence. So here's what you can expect to learn throughout this course. We're going to start with the fundamentals. So starting at the ground level, you'll gain a solid understanding of networking essentials in Swift. You'll learn how to make network requests, handle responses, and manage data seamlessly within your iOS applications. Next, we're going to move on to Swift concurrency. So we're going to be diving into that to write concurrent code that is safe and efficient, ensuring our apps perform at their best. We're also going to be using Async Await, which is a part of the Swift concurrency framework, and get hands-on experience with asynchronous programming using Swift's Async Await. You're going to discover how to write asynchronous code that's clean, readable, and highly maintainable. Guys, we're also going to cover unit testing in detail. So we're going to have an entire module dedicated to unit testing for our services and our view models to help you guys succeed in that regard as well. And we're not going to stop at the basics. We're going to explore the advanced networking techniques and architectural patterns like MVVM, dependency injections, caching data, and all of that amazing stuff, ensuring your apps are not just functional, but are also maintainable and scalable, and their performance is optimized. So why take this course, guys? So this is your ticket to acing technical interviews. So anytime you get a take-home interview, they're going to expect you to be able to have this type of knowledge and experience to write clean and professional code. And with my industry experience, I'll provide you with the insights and practice you need to confidently tackle the most challenging interview questions. And not just that, we're going to be demystifying these complex networking concepts. It's really hard to find information on this stuff out there, which is why I'm bringing this course to you guys. So there's going to be no more confusion or frustration when dealing with network-related issues. You'll have the knowledge and skills to troubleshoot and solve problems efficiently and implement the correct architecture patterns in your code. So whether you're a beginner looking to kickstart your iOS development journey or an experienced developer striving for excellence, this masterclass is designed for you. Together, we're going to transform you into a Swift networking expert, equipped to build exceptional iOS apps and shine in technical interviews. Get ready to unlock the full potential of Swift networking, guys. Let's dive in and make your iOS dreams a reality. Hey, what's going on, guys? Stefan here from App Stuff, and welcome to the first video in the course where we're going to be doing a deep dive into the world of networking and APIs for iOS development. So we're going to be going over what exactly those terms mean and going through some real life examples of what that looks like in a mobile application before we hop into Xcode in the next video and get started with building out our own mobile application to demonstrate these concepts. So let's go ahead and get started with what networking is. So networking, guys, is essentially the backbone of modern mobile applications. It allows your app to communicate with external data sources, servers, and services. And APIs, well, they're the gateway to accessing that data. So networking, in a nutshell, is the process of exchanging data between your app and a remote server on the internet. It's like sending and receiving messages between your app and the server. That data can be text, images, videos, or anything else your app needs. So networking is crucial because it enables your app to stay connected and up to date. Think of your favorite social media app like Instagram, TikTok, or YouTube. It's constantly fetching new posts and updates from the server, thanks to networking. So next up, guys, we have APIs. So what is an API? It stands for Application Programming Interface. So how does your app actually talk to these servers? Well, this is where APIs come in. And it's like a set of rules and protocols that allow your app to request and receive data from a server. So let's take a look at what that looks like. So here's how it works. We have the internet, and then we have our mobile client, let's say our mobile application, and then we have some data server or database where all of that information that we want exists. So how do we get from point A to point B, right? How do we get the information that we want from the server onto our phone? Well, our phone reaches out to that server via the internet, right? The internet is like the middleman that is going to serve as the gateway of communication between these two things. And once we send a request to the server through the internet, we get a response back from that server with the data that we are requesting. So in the case of the examples we talked about, that could be images to display in a post. It could be video data to display on like a YouTube app or a TikTok app and stuff like that, guys. And we're going to be going over how to do exactly that with the mobile application we're going to be building in this course. So we're going to be reaching out to a server to receive data about cryptocurrencies and display that information in our application. It's going to be super exciting, guys. And before we get started with the code, I just want to do a little bit more of a deeper dive into how this stuff works. So I just want to touch more on the process of what goes on from start to finish of making a network request and receiving that back the data from the server to display it on screen. So to interact with your API, we're going to be using HTTP requests. So that stands for Hypertext Transfer Protocol. And that's something that you guys have almost undoubtedly seen every time you use an internet browser. When you type in a URL, you'll see http:// blah, 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 blah. So that's how we're going to request information from a server, and that server will then send back a response to us. And we're going to deal with all the different types of potential responses we could get back. Sometimes you get a successful response and you can display information on a screen, or sometimes you get back an error. Something could be wrong with the client, something could be wrong with the server or the internet connection, and we're going to go over how to handle all of that stuff. So that's just a quick introduction as to what networking and APIs are, guys. Remember, this is key to connecting your app with the world, and APIs are your means of communication. So without any further ado, let's go ahead and hop into the next video where we're going to set up our Xcode project and take a look at our API documentation so that we can see how we can get started with building out this amazing application we're going to build here, guys. So get excited for that. We will see you in the next video. Peace out. What's going on, guys? In this video, we're going to start off by creating our Xcode project and then take a look at our API documentation so we can start talking about how we're going to fetch all of this crypto data and then get into the implementation of how we're going to fetch that to start off the course. So let's just go ahead and create our Xcode project. I'm going to call this networking tutorial and hit next, and I'm going to hit create. And we are just going to start this off, guys, by setting up our project directory over here in the project navigator. So I'm going to make a couple folders, one for my app, and then we're just going to take this networking tutorial app file and move it into that app folder. And then I'm going to create another one called core. And within core, guys, let's go ahead and create a subfolder called all coins, and that's what this all coins sort of view is going to represent here. And then we're just going to go ahead and create a couple subfolders for that. So we're going to create 3 guys under all coins, and it's going to be our models, views, and view models. So we are going to be using the MVVM architecture here, guys. So this is how we're going to set that up. And let's just go ahead and take our content view and see if we can just move it up to that view folder, and that should look good, right? So let's go ahead and just run our application, and we should just see hello world popping up. And if you guys resume on the preview, it gets annoying here when you move the file. So I think if you like just go and like go to your app file and then maybe go back to your content view, it should work successfully, right? Weird bug that Xcode has, but it's not that bad to fix. And I'm just going to move this app file above my core folder to keep this all alphabetical and organized. It is worth it to put effort into organizing your project directory, guys. It really makes your code easier to manage and it keeps everything really nice and organized. So now that we have our project all set up, guys, I want us to start taking a look at the API that we're going to be using to fetch all of this data about our cryptocurrencies. So just go ahead and open up an internet browser and do a Google search for CoinGecko API. And we can just click on this link right here, coingecko.com. And you guys can see that this is a comprehensive cryptocurrency data API for traders and developers. So let's go ahead and click on this Explore Docs link. And this is going to take us over to the API documentation. So anytime you guys are using an open API or any kind of API, really, it should have some documentation that gives you instructions on how to utilize that API. So basically what we need to do is reach out to certain endpoints, right? So, or certain URLs. And once we do that, it's going to return some data to us. So we're going to request some information from this API using a particular endpoint, and we can see the list of options we have here for the endpoints that we're going to be contacting. And each one of those endpoints is going to give us back a different set of data and different types of data. So let's go ahead and take a look at their like sort of interactive API documentation here. This is really cool. So let's take a look at this first option here. We have a ping, right? So anytime you ping a server, guys, it's just going to check that status of the server and it's going to give you a response code. So we know that if we get a 200 code back, we're good to go. If we got something like a 404 code back, we know that something's wrong with our API and we would maybe want to display that information to the user and stuff like that. And they have this option here to try it out, right? So if you guys hit execute, it's going to give you the request URL here. And this is what's known as our endpoint, right? So we're going to reach out to this particular URL and add ping to it, and then it's going to give us a response, right? So it says Gecko says v3 to the moon, whatever that is, and it just gives us back a status code. So literally, guys, you can take this and go ahead and paste it in your URL bar and see what happens, right? You can just say ping, and this is the response that we get back. We notice that we are all good. So let's go ahead and take a look at another example, right? So let's go ahead and try to see if we can get a price of something. So let's go ahead and hit this try it out button, and that's going to allow us to edit these fields and pass in the parameters that we need to get the particular price we're asking it for. So in this IDs, guys, go ahead and just pass in Bitcoin or any cryptocurrency that you want, really. And then we also need to specify the currency that we want it to give us back in. So let's do USD. And you guys can now just go ahead and hit execute. And you guys will notice that I get a 200 code and I get a response body. And it's going to give me the current price of Bitcoin. And you guys could cross-reference that with an actual cryptocurrency API like TradingView or Coinbase, and you should see that that matches up directly. So that's really cool, right? And let's maybe try another one. Ethereum, and hit execute. And this will give us back the price of Ethereum. So guys, this is just really to illustrate how these particular endpoints will give us back different types or sets of data, right? So you notice here they give us the request URL, which is really, really cool. And once again, you guys can paste this into your browser and it will give you back this sort of response in this JSON format. And JSON stands for JavaScript Object Notation. If you guys don't know what that is, we are going to break that down a little further once we actually get into fetching this information in our application. So basically, guys, that's pretty much going to wrap it up for this video. I just wanted to get our project set up and take a look at the API to see how we're going to be using this stuff. In the next one, we're going to get into actually implementing this stuff in our application and using these endpoints to reach out to this API and ultimately download that data to our device so that we can start to display it on the phone. So get excited for that one, guys. That's going to wrap it up for this video. We'll see you there. Peace. What's going on, guys? Welcome back. Hope you are having an amazing day. In our last video, we went over how to set up our Xcode project, and then we also went through the API documentation to see how we're going to be using it to ultimately fetch data to display in our application. So we're going to get started with our networking implementation in this video. And we're going to start off by using something called completion handlers. So there's a couple different ways we can fetch data with Swift. One being completion handlers, the other being the async await API. We're going to start this networking course off with completion handlers. So for those of you who are already familiar with how to use completion handlers, I still highly recommend going through this section because there will almost undoubtedly be some things that you might not know about completion handlers or some of the problems that arise with them or how to use them before we jump into the new async await stuff. So for those of you who are unfamiliar with both, get excited because this is going to be a really amazing journey with how to network with Swift. So anyway, guys, now let's go ahead and get started with our implementation. So we're going to be creating a view model here. And the responsibility of this view model is going to be to fetch our information from our API and supply our view or provide our view with that data that we get back. So let's go ahead and just create a Swift file in our view model folder, and we're just going to call this coins view model. So we're going to go ahead and create a class, coins view model, and it's going to conform to observable object. So if any of this is confusing to you guys, I highly recommend checking out the Swift Fundamentals and SwiftUI Fundamentals Bootcamp. We're not going to be doing a deep dive into view model or MVVM architecture. We're kind of assuming that you guys already know what that is. We're going to touch lightly on it just to do a quick recap, but this will not be an in-depth explanation into the MVVM architecture pattern. This is all about networking. So let's go back to our view, guys, and we're going to create an instance of our view model. It's going to be a state object, and we're going to call it coins view model. So one more time, the responsibility of this view model is going to be to fetch information from our API and supply our view with that data. So let's go ahead and see if we can create some dummy data to start this off, right? Just to get a framework of what we're going to be doing. So let's go ahead and create a text component, and we're going to say like Bitcoin, 25,000 bucks, right? And let's go ahead and resume our preview. And this is ultimately sort of what we're going to want to fetch from our API. Okay, we want to fetch the price for a particular coin and display it in our view right here, like this. And maybe we can add a comma or something like that. So let's go ahead and see if we can set our view model up to do that with some dummy data. So here I'm going to go and say at published var coin and at published var price. And they're both going to be blank strings. And I'm going to make a function here, guys, called fetch coin or fetch price. And for now, we're just going to go and say, supply these values with some dummy data. So let's say like self.coin equals Bitcoin, and maybe self.price equals like 30,000. And wrap it in quotes. And let's go ahead and replace this text that we see here with the data that we want to get back from our view model. So here we're going to use some string interpolation. I'm just going to delete this and say interpolate viewModel.coin and interpolate viewModel.price. And you guys are going to notice that all we get back is this little colon, right? And that's because, oops, sorry guys, .price. We haven't actually called that fetch price function, right? So there's a couple ways we can do that. We can go back to our view model, and when we initialize this thing, we can just call fetch price, right? And then we can go back to our content view, and we'll see that we're getting back the data from our view model that is coming back from that fetch coins function, right? That fetch coins function is just populating these two properties with some hard-coded data, Bitcoin and 30,000. So what we're going to do now is go over how we can actually fetch this information from our CoinGecko API. So if you guys remember, I'm going to go and pull up the API documentation once more. We took a look at this simple section, right? And this is how we get the price of a coin. We need to pass in the coin that we want the price for and the currency that we want the price to come back in. In this case, we're looking at Bitcoin and USD. And the API will automatically generate this request URL for us. So if we change those parameters, guys, the request URL will change and it will give us back the data corresponding to the parameters that exist in this request URL. To see an example of that, let's go ahead and change Bitcoin to Litecoin. And maybe we can do it in euros or something. And you guys will notice that this gives us back Litecoin in euros, right? And you guys notice that these parameters change in the request URL, right? We see that currencies is now euros and the coin that we want is Litecoin. So if I change it back to Bitcoin and USD and hit execute, my URL request updates and the data that comes back updates as well in correspondence to what this request URL looks like. So we are going to copy and paste this URL, guys, and we're going to go back to our Xcode project and create a URL from that. So we're going to say let URL string, and we're going to paste that guy in there just like that. So even though this is like in HTTP format and this is an actual like represents a URL, in Swift right now, this is only represented as a string. So we need to actually take this URL string and create a URL object from that. So let's go ahead and go over how to do that. We're going to say guard let URL equal URL string from our URL string. And we're going to say else return. So if you guys have some networking experience, this should all be pretty familiar right now, right? We're converting this string here into an actual URL object. And then we are going to now get to the exciting stuff where we actually reach out to this URL and download the data that comes back from it. So in order to do that, guys, we are going to say URL session dot shared dot data task. And you guys are going to notice that we get this option that says with and completion handler, right? So it's going to ask us to pass in a URL request. We already have our URL here. And then it's going to give us something back called a completion handler. So if you guys read the documentation in the autocomplete window, it creates a task that retrieves the contents of a URL based on the specified URL request object and calls a handler upon completion. So we're going to do an in-depth breakdown of what exactly a completion handler is and how it works and all that stuff. For now, I just want us to execute this function and see what happens when we do. So guys, just go ahead and pass in your URL that we created right here. So you guys notice it asks us for a URL request. We can, unfortunately for us here, we can just pass in the URL we just created. But if you guys tried to pass in that URL string, you guys are going to notice we get an error in our compiler, right? It's going to say something weird like this, but basically it's because the data types don't match up. We have to make sure we pass in a physical URL object. And once again, we used this string to create that URL. And then here's the interesting part about completion handler, guys. If you tab over to this and you hit enter, you guys are going to notice it opens up a block of code. And we get access to these three parameters. So basically, this is the stuff that's going to come back to us in this completion handler. And once again, guys, don't worry, I'm going to explain that in detail. Let's just go ahead and name these properties data, response, and error. And let's go ahead and just add a print statement here. So I'm going to say print did receive data. And we're going to do some string interpolation and just pass that data into that print statement. And something that we have to do to make sure this actually executes, guys, is say .resume. So make sure you don't forget this. This trips developers up all the time. Not sure why Swift makes us do this. It's honestly kind of annoying. But with completion handlers, you do have to call this .resume guy to actually execute the task. So this data task is going to reach out to that URL and download the data that comes back from it. So let's go ahead and physically run our code on the simulator, guys. This won't work in the preview. I wish print statement worked in the preview, but they don't. And you guys will notice that we are getting this print statement back, right? So we've actually received data from our API at this point, but it's in like a raw data format, okay? We got 25 bytes of data back. So we want to actually transform this data into like a readable string so that we can ultimately update these properties up here and provide our view with that data and have it update once we receive this information. So before we do that, guys, I want us to do a breakdown of what a completion handler actually is and what is happening behind the scenes with this data task function. So
I want us to add some print statements here really quickly, and this is going to help us get a better understanding of this. So I'm going to say print, and make sure you add this before the URL session code, fetching price. And then we'll keep this print statement here, did receive data. And then we're going to go after that URL session. And we're going to say print did reach end of function. And I want you guys to pay very close attention to the order that these print statements come back to us in the console. So let's run our code again. And you guys are going to notice that we get fetching price, and then we get did reach end of function, and then we get our did receive data from our completion handler back. So this is pretty mind-blowing, right? Even though we wrote this before this guy, so we wrote did receive data before we reach the end of the function, we only get this print statement about receiving the data after we say, hey, we reached the end of the function. So this is the core foundation or essence of how completion handlers work, right? Essentially, guys, this data task, it takes time for us to reach out to the API, retrieve the data, and then get it back onto our device. So the way this code executes is this guy is going to execute, and we see that happening first, and then this URL session data task is going to execute. But this the code that is inside of this completion block isn't going to execute until we get a response back from our server. Let's say that takes 1 second, right? Our code is going to continue its execution. That's why we see did reach end of function before we see that we receive the data back. And whenever that API call completes is when we're going to enter back into this completion block and get this print statement back. So this is why it's called a completion handler, or oftentimes referred to as a callback, right? It's going to make a call to the API, and then we're going to get a call back from the API whenever that process completes. But there's no guarantee as to when that's going to happen. We do know it's going to take some time. So this is referred to as our code executing asynchronously or non-sequentially, right? So even though we have this line-by-line execution, this comes back after we reach the end of the function because this API call takes time. So I really just wanted to explain that concept to you guys. I think that's a really good stopping point for this video. We successfully reached out to our API and fetched some data, and we have a better understanding of how completion handlers work, guys, and sort of the process that this undergoes. And, just another quick note is this is all the stuff we get back from that callback. So we get some data back, we get an HTTP response like, hey, 200 code, you're okay. Or we could potentially receive an error. And we're going to go over how to use all of this stuff inside of our completion handler in the next video before we ultimately start going over how to update these published properties here so that we can update our view with the data that's coming back from our API. So get excited for that, guys. We'll see you in the next one. Peace out. What's going on, guys? Welcome back. Hope you are doing well. In our last video, we went over how to reach out to this particular API endpoint and actually retrieve some data back from our API. We also went over the concept of a completion handler, how they work, and we noticed some interesting stuff with like the order that these print statement came back in, right? And just to do a quick recap on that, this code is going to execute asynchronously, and asynchronously means non-sequential, right? So we notice that we get this print statement first, this one comes second. Let me add some comments so to just iterate this concept more clearly. And this one comes back third, and that's because reaching out to our API to fetch this data takes time, guys, and we don't know how long that's going to take. And we don't really care, right? We just care that we receive some sort of callback when it's done. And that's what's going to happen when we enter into this block here. So when we enter into this block, we know that we receive some data back. We could potentially receive an error back as well. And we're going to go over how to use all of these properties that we see here. But the main concept that we want to understand here, guys, is that our code continues on with its execution, and we only get this print statement back whenever that process completes of downloading our data from the API. So that's why it goes 1, 2, 3. So that's the concept of a completion handler and a callback. Now what we're going to do in this video is get into how we can actually start parsing this data or transforming it so that we can use the data that we get back to update these properties and ultimately update our view with data that comes back from the API. So guys, I'm going to pull back up our crypto documentation for the API. And we notice that this is what our response body looks like when we reach out to our API and get that data back. But it's not coming back to us in that format right away. It comes back as raw data. And we have to do some sort of parsing or transformation to get the data to look like this so that we can ultimately use it somehow, right? The name of the coin and the price of the coin is what we're looking at in particular. We could even use the currency if we want. So this is what's referred to as JavaScript object notation. So this is basically a simple and lightweight data format that's used for storing and exchanging structured information between different programs or systems. So basically, guys, I can just get this JSON data back or JavaScript object notation and parse this information to get the data that I need out of it. So this is a really common format for how things come back in terms of fetching information from an API. So if I'm an iOS developer, I can get data back in this format. If I'm an Android developer or a web developer, I can also receive data in this format and parse it based on the needs of the particular system or client that I'm working with. So we're going to go over how we can start transforming that data into, that JSON format that we want so that we can ultimately read or update these properties we have in our view model here. So Swift gives us something called a JSON serializer that's going to allow us to do this. So we're just going to go ahead and say guard let data equals data else return. So guys, this comes back as optional, right? Because let's say this API call fails, it's not going to give us any data back, right? It's going to give us back an error. And we're going to go over how to handle the error a little bit later on. Right now, we're just going to work with the data. So we're going to make sure that we have this data before we try to use it anywhere, right? And then, guys, we are going to say guard let JSON object equal JSON serialization dot JSON object. And you guys are going to notice here that we just need to pass it some data and it will automatically convert that data into a JSON object for us, right? So here we're just going to pass in the data and we're going to say else return. And guys, we do need to add this try statement in front of it. And we'll go over tries and do's and catches a little bit later on. Right now, I just want us to focus on how to parse this JSON data. Okay. So now let's see if we can print out that JSON object. So let's go ahead and say print JSON and print out the JSON object and see what we get back. So let's run our code one more time. And let's see what happens. Okay. So our print statements come back and you guys check that out. We get that beautiful JSON object back just like that. We see that we have Bitcoin, USD, and our price, right? So while that's a step in the right direction, we still can't really extract any data from this JSON object, right? We don't really have a way of doing that with this raw JSON data. So we need to transform this into a more concrete Swift data type so that we can extract data from it accordingly. So we're going to be utilizing something called a dictionary to do that, guys. And if you guys don't have any familiarity with what a dictionary is, I highly recommend taking the Swift Fundamentals course before proceeding any further with this networking course. But basically what we're going to do is transform this JSON object into a Swift dictionary type. And a dictionary is just a key value system. And this is exactly what JSON objects are. They're key value structures, right? We just need to cast this JSON object as a dictionary so that we can use it accordingly in Swift. So we're just going to go here and in the JSON object creation, we're going to cast it as a dictionary that looks like this. It's going to have strings as the keys and any object as the value. And guys, that's because Bitcoin here is the key. Basically, all of our dictionary keys are going to be strings, and we can have any sort of value associated with the string key. And we'll go over how to parse the value in just a second. Let's just go ahead and run our code again and see what this JSON object looks like now. So you guys are going to notice that it now has brackets, right? So we're actually successfully casting this JSON object as a dictionary now, which is awesome. So the only thing we need to do now is figure out how to cast the values of this dictionary as well. Like, we don't want any of these equal signs here. We want a full dictionary object type for all of our JSON data. So we're basically just going to do the same thing we did to cast this dictionary for this guy here. So this is a key and a value. So we just need to break that down one step further, right? So here, guys, we are going to just delete this, and we're going to say let value equal JSON object. And to access the value associated with a key, this is what we're going to do. We're going to go here and say Bitcoin, and we're going to cast this as well. And you guys can say string any, but we can notice that this price is coming back to us in an integer format, so we can just cast this as an integer as well. So now we have a concrete Swift data type with this dictionary to parse our value as well, guys. So let's go ahead here and just say print our value and run our code. And you guys are going to notice now that all of the nasty curly JSON brackets are gone, and that we are getting this all of this data back in to us in dictionary format now, which is incredible. That means we can actually start reading this data from the dictionary to update our published properties up here and give the data back to our view. So guys, we are just hard coding this Bitcoin key coin for fetching our price. We can make this a little bit more dynamic in a second. What I want us to do is just get the data back from this value to update our price. So here we can, for now, just say self.coin equals Bitcoin, and we can say self.price equals this injected value with our string interpolation, and we're going to say value, and the key is going to be our USD right there. So basically, guys, in order to get the value, you need to just say, hey, go into the dictionary and find the key that we want the value for. And in this case, it's USD. And once again, this isn't super dynamic. Like, if we were to pass in euros or a different coin, we would want to display different data, and we would have to update this, which we'll do in a second. I just want to see if this stuff is working. Let's also go ahead and just guard let this statement, guys, so our value isn't optional, and return. And let's go ahead and run this code now. And you guys should notice that something really exciting is going to happen. We are going to get back this data here, guys, right? This is looking super, super good. But you guys will notice that we are getting these purple warnings back from our compiler, and it says publishing changes from background threads is not allowed. Make sure to publish values from the main thread. And we are going to go over what this means in detail in the next video. I'm going to give you guys a comprehensive breakdown of threading, background threads, the main thread, multi-threading, and all of that stuff with diagrams. But for now, I just want us to fix this problem, and we will go through a breakdown in the next video. So really quickly, guys, just go ahead and Command X to cut those two lines of code. And we're going to say dispatch queue.main.async. And basically, this is going to get us back onto the main thread so that we can update these properties that will ultimately update our user interface. So another thing I want us to fix really quickly, guys, is safely unwrapping this value. So we want to get this price back as a non-optional property. You guys see it's displaying as an ugly optional in our user interface. So to do that, we could just say guard let price equal value USD else return. And then we can just go and inject our price here. And maybe put a $sign in front of it. And let's go ahead and run this. And you guys are going to notice that that looks way better, and those purple errors go away. And once again, we'll explain that in the next video, guys. How I want to wrap this up is how we can make this function a little bit more dynamic, just to show you guys how to make your code a little bit more dynamic, just so we're not constantly just fetching the data for Bitcoin. We ideally would want to be able to like fetch data for any coin, right? And this is going to help us figure out how we can pass values into something like a URL string so that we can get dynamic data back in our application. So basically, we don't want to hard code this Bitcoin value, right? We want to be able to pass in any coin to this function and maybe even have the user be able to like search for a coin themselves. So we definitely want to pass in like a coin right here to this function, and then we're going to inject it into this spot right here. So right after the IDs and the equal sign, you guys can delete that and go ahead and make sure that everything else stays in place. Make sure it's IDs equals, and we're going to inject this coin here. And then make sure this stays the same as well, and VS underscore currencies equals USD. And then guys, up here, we can say, hey, we can now pass in a coin, and maybe we can say Bitcoin, right? And now what we want to do is make sure that we are not hard coding Bitcoin in the other places in our application, right? So basically, guys, when we get this JSON object back, we want it to be for whatever coin we're requesting the data for. So this is going to be coin, and then the coin that we update our UI with is going to be the coin that we pass in here. It does come back as lowercase, so we're going to say coin.uppercase. And if we run our application, everything should look exactly the same. And then what I want us to try to do, guys, is pass in some different data. Maybe we don't want it in all caps. So there's a different way of doing that. We could say coin.capitalized. Yep. So capitalize will just uppercase the first letter of the string. Uppercase will uppercase the entire string. Okay, so let's try it with like Ethereum or something, guys, or Litecoin, and see if it works. And we're going to notice that it doesn't, right? So this is going to help us figure out how to go through some debugging in our code, right? So we notice here, guys, that based on our print statement, we're still getting data back, right? So we are successfully receiving data. So that means we are not getting an error, which is good. We're just doing something wrong in terms of parsing that data, right? So let's see if we can print out the JSON object to see what it looks like, to make sure that we're casting all of this stuff correctly. And we'll see where we went wrong here. So just go ahead and print JSON object, guys. And make sure you do that before the guard statement of the value. And let's run that again. So you guys are going to notice that we get back Litecoin, but it's not an integer type, right? It's actually a double. So here we're trying to cast this value as a string to integer dictionary, but it's this is actually a double value, so that cast is failing, and this return statement hits in our guard, and it doesn't go past this point. So if you guys want to get a more detailed error description in the else statements of your guard, you could say print like failed to parse value. And you could do that for all of the other print sort of guard statements that you have here. You could say maybe like failed to get price, and then you just have to say return. And this will just help you guys figure out what's going wrong and where in your code, right? So this is sort of just diving into a little bit of error handling and debugging stuff. So now all we need to do is just modify this to a double data type. And you guys notice that if we run our code again, that we're going to get Litecoin back as $64.06. So that looks really, really good, right? Next, guys, let's see if we can do maybe like Ethereum or something and run our code. And you check that out, guys. We're getting Ethereum back, so we're successfully retrieving dynamic data from our API. You guys could maybe do the same thing with the currency if you wanted to get different currencies back, and then you would just replace this guy for the value here. But this gives you guys an idea of how to dynamically fetch data from an API, right? And we're using completion handlers to do that. We're updating our UI with data that's coming back from the API. So this is part of the foundations of what you're going to be doing as an iOS developer in terms of networking, guys. You're going to be reaching out to some sort of API that's going to have some endpoint like this. You're going to get the data back. You're going to parse it, so that you can use it in some sort of readable format with like Swift object types, and then you're going to update your user interface with the data that you get back from that API. So that is one, like I said, one of the core foundations of being an iOS developer. And this is a really good starting point for this networking tutorial that we're going through. In the next one, guys, we're going to talk more about threading, and then we're going to go over how we can handle our responses and our errors here as well, before we get into the more exciting stuff like actually fetching all of these coins from the API and displaying this really beautiful user interface here. So thanks for watching this one, guys. We'll see you in the next one. Peace out. What's going on, guys? Welcome back. In our last video, we went over how to parse the incoming data that we were getting back from this data task into usable formats so that we could extract the data that we need and ultimately update our UI. So that brings me to my next point, where if you guys remember, we were getting these weird purple errors, right? Where it was like, hey, you're trying to update the UI from a background thread. That's not allowed. You have to do that on the main thread. So in order to solve that problem, we did this dispatch queue.main.async, and that got us back on the main thread where we were able to update our UI. So there's a lot to unpack there, and that's what I want to focus on in this video. I want us to talk about the concept of threading in a program, the difference between main threads and background threads, and why this stuff is important and why it all ties together, why it's important for you to know moving forward, and all of that stuff. So I have this diagram that I made for you guys to explain the concept of threading in general and the difference between main threads and background threads. So to start this off, guys, what is a thread? So it's essentially just a separate path of execution within a single program. So a thread is responsible for performing some amount of work or doing some task, right? So in our case, we are fetching information from an API to display price data about a cryptocurrency. So that's a task that our program is executing. That task happens on some sort of thread. Now, you guys could imagine if our application got more complex and we were fetching information from multiple APIs, say about stocks and NFTs and cryptos, and all of those things had separate APIs, those are processes that all need to execute ideally concurrently, right? We would want those to happen at the same time. All of those processes happen on their own individual threads. So a thread is essentially just a path of execution within a program. So that brings me to my next point. What is the difference between the main thread and the background thread or background threads? And how does that relate to our user interface? So let's start with the main thread, guys. So in any program, the main thread is the primary flow of execution. So this is where the core tasks of the program are carried out. And in an application, like a mobile app, like an iOS app, all of the user interface updates happen on the main thread, because this is the primary path of execution. It gets the most computing power, the most juice, and in order for the user to have a pleasant user experience that involves smooth UI updates, like imagine in our UI here in the completed app, we want this scrolling to happen smoothly. We want the taps to happen seamlessly without any lag. You want your user interface to be as smooth as possible, and that's all running on the main thread. So that brings me to background threads, right? So background threads are processes that happened in the background or under the hood, so to speak. And these are separate from the main thread, right? So when you do things like fetch information from an API or perform some computationally intensive task like a complex algorithm and stuff that doesn't really need to be happening on the main thread, you do those on background threads. Why is that? So essentially, guys, if you were to perform some API call that was involved downloading a lot of data, say downloading large images or a large data set, and you did that on the main thread, it would cause your user interface to potentially freeze up and get really laggy because you're performing a complex operation that takes computational power, it takes up memory, it takes up network usage, and you're doing that on the main thread, and you're essentially blocking the user interface from running smoothly and doing what it needs to do. So all of those computationally intensive processes or API calls you want to happen on background threads. So that brings me to my next point, where it's like, what happens when you get information from a background thread and then you need to pass it back to the user interface? So that's what we saw with our code when we went and got the data that we needed, right? But then we tried to modify the user interface by populating these published properties. So when we set these published properties, it published that changes over to the view and ultimately redraws the user interface for the user. So we are currently on a background thread inside of this URL session. So thankfully for us, Swift automatically manages the transition of going to the main thread onto a background thread. And this data task guy happens on a background thread automatically because you don't want to involve blocking your main user interface while an API call happens. You just want it to go get the data, and whenever it's done, then you supply or you update the data so that the user interface can get updated. And you want that to happen on the main thread, but only when you're done doing the process that you need to, right? In this case, fetching data from our API. So back to our diagram, guys. If you try to update your user interface directly from the background thread, it's going to give you an error, right? So this is illustrating that we can have multiple background threads, and if we try to update the UI from that background thread, it gives us an error. So basically what we need to do is go from the background thread back over to the main thread, and the main thread can then update the user interface. So there is some transitioning that happens between threads, and we just need to make sure that we do that stuff correctly so that we don't run into any sort of problems in our application that could potentially lead to crashes or poor user experiences, right? So what I want us to do now, guys, is hop back into the code and add some code to our program to really showcase how this stuff works and give you guys a better understanding of that through use of an example. So let's go back into our coins view model. And I want us to go ahead and see if we can print out the thread that we're on throughout the process of this function. So when the function starts, let's go ahead and say print thread.current. And this returns the thread object representing the current thread of execution. So let's see the thread that we're on when we start this function. And then let's see what thread we enter into when we go into the completion handler. And then in this dispatch queue.main.async guy, let's go ahead and print the thread out again. So let's go ahead and run our code, guys. Oops, I made a capital P there. And let's see what these print statements give us back, and let's see how that relates to our diagram. So we see that the first time we get that print statement, we are on the NS main thread, right? And then we see that we go fetching price, and then we see did receive end of function, right? And then we enter back into our callback or our completion handler after we get our data back. And then, guys, we see that we're no longer on the main thread. We see that we're on just a regular NS thread. So this represents switching over to a background thread. So if you guys remember what I was talking about, Swift automatically handles that for us in this data task function. They automatically switch us over to a background thread when we are doing this data task, which is really nice. We don't have to do that thread management ourselves. And then the interesting part, guys, is that the third time we get this print statement, we notice that we're back on the main thread, right? So once we get to here, we go back onto the main thread so that we can ultimately update our UI. So that is exactly what we're seeing here in our diagram. The program starts out on the main thread, it goes to a background thread, and then when the background thread is completed with its processes, we get back onto the main thread and then update our UI. So I want us to add one more thing in the code, guys. Let's go ahead and add another fetch price. Litecoin. And let's go ahead and run our code again and see what happens. So we get some interesting stuff back here, guys. So let's unpack this and break this down. So we notice that the function gets called once, and we see fetching price, and we reach the end of the function, and we're on the main thread. So that represents the first time fetch price for Bitcoin is called. And then the second time, we notice that we're on the main thread, we're fetching price, and we reach the end of the function. That's when the fetch price for Litecoin gets called, right? And then we notice that when we're here, we are now on a background thread, and we get back the data for Bitcoin, and then we update the main thread once we go onto this dispatch queue.main guy. And then after that, we enter onto a different background thread to fetch the Litecoin data, and then enter back onto the main thread to ultimately update our user interface with the information that's coming from that particular thread. So this really showcases this the final state of this diagram, or the state of this diagram, where we have two background threads that are executing concurrently, right? One was thread 3, one was thread 7. One is in charge for fetching Bitcoin data, one is in charge for fetching Litecoin data. And we notice that we have to get back onto the main thread from each of these guys to update our user interface. We cannot do so directly from our background threads. So that just gives you guys a comprehensive and a visual breakdown of what exactly is going on with this threading stuff. And it's important to understand, guys, because you always want to make sure that you are being thread safe, and you're doing things on the correct threads when you are using networking within your application. And it doesn't have to be networking. It could be any sort of complex task, right? So like I said before, if you are executing some algorithm, right, like a ranking algorithm for like a social media feed or something that takes a lot of time to execute, you're going to want to do that on a background thread. So you want to keep the main thread as clean as possible, because you want your user interface to be as responsive as possible. So that's why this stuff is important here. It's important to understand this to make sure you're developing quality apps with quality user experiences. And that's going to wrap it up for this video on threads, guys. In the next one, we are going to get into error handling and how we can handle different responses that come back from our callback here to really get a full comprehensive experience and end-to-end functionality of what to do if things go wrong. So get excited for that. We'll see you there. Hey, what's going on, guys? Welcome back. In this video, we are going to be getting started with how to handle our errors. So you guys will notice that in this completion handler, we get back a potential error, a potential response, and some potential data. We're going to be going over how to deal with these other two potential properties we're getting back. We've already gone over how to deal with the data, but now we're going to be taking a look at potential responses and potential errors. And the reason I say potential, guys, is because if you hold down Option and click on this data task guy, all of these properties are optional, right? And there's a reason for that. There's a reason that error is optional, mainly because if we get a successful response back, there will be no error that comes back, right? And if we get an error, then we're probably not going to get any data back, right? We may not. So we can't guarantee that we're always going to have one of these things. So that's why by default, Swift makes it optional for each one of those properties. So before we get into handling our errors, guys, I do want to clean up a bunch of these print statements. This function has gotten really messy with all of them, and we don't really need them anymore. So let's start by deleting this guy right here. Let's delete that one. Let's delete print thread.current. Let's delete printing out this JSON objects, and let's delete this thread.current. We're going to leave this one in here, and that should be good for now. Let's actually delete this one too. Okay, so, and this guy at the end. So our function looks way cleaner now. Now we can actually start to get into how to handle these errors. So we're already checking for the data, guys, and we are safely unwrapping it before we try to use it. Let's do the same thing with our error, okay? So we want to check for the error before we do anything else, because if there is an error, then we don't want to continue with the rest of the execution of this code. We just want to say, hey, there's an error. I want to stop here. So what we can do is say if let error equals error. Let's just go ahead and say print. Let's add this prefix call and say debug. And this is going to help us filter through a bunch of stuff in our console, guys. I like to add this to my print statements just so I can filter down and find what I need in there in case there's a lot of jumbo. So we can just say failed with error. And let's pass in that error with some string interpolation and say error.localized description. And what you're going to want to do from there, guys, is say return. And that's how we can guarantee that we'll stop execution of our function if we run into an error, right? And the reason we don't want to use a guard statement for that, guys, is because if you were to say guard let error equal error else return, this is going to stop the execution of your function right here if there is no error. So if the no error comes back, it's going to hit this guard statement and it's going to say, hey, we didn't get an error, so we're going to stop there. That's not what you want to do, right? You want to enter into this if block and say, hey, if there's an error, print it out and then stop. But if not, just keep going. So that's what that's going to do. Let's go ahead and run our code just to make sure everything is still working as expected. Okay, so we still get back our pricing data, and that's looking really good, right? So what I want us to do now, guys, is see if we can like force an error to happen. So inside of this URL string, let's maybe go ahead and just delete from the API, like delete the I or something, right? Make sure you delete something from the root URL. And this is going to give us an error because it's going to reach out to this or attempt to create a URL from this and reach out to it, and it's going to get a bad response because this URL doesn't exist. So let's run this again. And let's go ahead and filter our console. And you guys will notice that, hey, we got an error, right? And nothing is showing up on screen because we have that error message. Or we got an error when we tried to fetch our data. So we get some detailed description. A server with a specified host name could not be found. So something we might want to do here is like have a publish property for an error message. Var error message, and it's going to be an optional string. And we could say like self.errorMessage equals our error.localized description. And then we could go back to our view and we could say, yo, if there's an error, then show that. If not, then we're going to show the other stuff, right? So we're going to say if let error message equals viewModel.errorMessage and else. And then we could just say text error message else paste our code back in there, right? So if an error happens, it's going to show that error. If not, it's going to show us the result of our API call. So let's go ahead and run this, guys. And you're going to notice that we actually get the error message back showing up on our screen, which is great, but we are getting this nasty purple error again. And it's for the same reason we were getting it before. It's because we are trying to update our UI from a background thread. So we need to be able to get back onto the main thread from here. So we could either go ahead and just copy and paste this dispatch queue.main.async, or what we could do is just wrap this entire block in dispatch queue.main.async, and then just go ahead and paste all this stuff and put it in there. And then we could take this stuff out of this dispatch queue guy and put it in here. Oops, copy and pasted the wrong thing. And so guys, as soon as we get our response back, we're going to hop back on the main thread. It's okay to do this stuff on the main thread, right? These are really, really lightweight options. This is in practice or in theory not the best thing to do, but we wanted to avoid having to type this guy out twice to get back onto our main thread to display our error or to display this. And this is just something that we're doing for testing purposes. We're going to create a much better implementation than this here. I'm just doing this to, once again, showcase the importance of understanding threading here, guys, and what can go wrong if you don't do this correctly. So we notice that purple error goes away, and we notice that, hey, we're getting back this error message. So that's great, right? Now we have a way of handling our errors and displaying some sort of message to the user if an error happens. And if we go back to our API string or URL string and just add that letter back to make sure the URL is good, and we run that, you guys are going to notice that, hey, we get that data back correctly and nothing went wrong. So that's looking really, really good, right, guys? So next up, we want to talk about how we can handle this response. So the response is going to have a status code associated with it. It's treated as an HTTP URL response. And I'm sure you guys have seen that stuff before. Like if you go to a web page and that web page isn't available, it's going to say, hey, there's a 404 error or something like that, right? So let's see if we can make sure that our response is good as well, just to be extra safe with our handling here. So guys, let's go and introduce another guard statement. We're going to say guard let HTTP response equal response as HTTP response URL response. Oops, HTTP URL response. And we're going to say else. So if we don't get a response back, then we want to stop the function here. So we can use a guard check here to make sure that we have this response before we go any further. And we're just going to say print, or we could just say self.errorMessage equals bad HTTP response or something like that. And then we're going to say return. And then guys, we can take this a step further and say guard HTTP response dot status code equal 200 else print debug, or sorry, self.errorMessage equals failed to fetch with status code, and we could inject that status code, HTTP response dot status code. So this will give the user back the bad status code that happened, and we can just say return from there as well. So this is just to illustrate how we can handle the response, guys. And you know, I'm pretty sure it's always going to be 200. So let's just go ahead and see if we can print that out. Debug response code is HTTP response dot status code, and let's run our code again. And you guys should notice that we get a print statement saying it's 200 and our price is good to go. And then let's see what happens once again if we delete that I from the API in our URL string. And you guys notice it hits the error block. It doesn't hit this HTTP response block. So let's see what happens if we comment this out and see if it would actually get into one of these guys here. Yep, so we got a bad HTTP response, right? So that just adds another layer of protection and error handling to our data fetching, guys. And this is really the foundation for what we need to do to start getting into the concept and idea of error handling. And this is something that's really important to do, right? You want detailed error handling in your application, and we're going to do a much more comprehensive breakdown of error handling as we go. This is just to give you guys an introduction to how this stuff works and how we can use it in our applications. So the reason you want to take the time to handle your errors, guys, is because you want to know as a developer what's going wrong. And if anything goes wrong, you also want to let the user know what's going wrong to improve their user experience, right? Like they might not have an internet connection, or our server could be temporarily down. And communicating to the user what's wrong is going to be very important. And it's also going to be very important for us to know what's going wrong as developers so that we can debug our code easier, right? So this, like I said, guys, is going to wrap it up for this video. That's just an introduction to error handling. In the next one, we are going to go over how we can extract all of this code into something called a service file, and how we can improve the architecture of our code here and start to code this out a lot more professionally. So thanks for watching this one, guys. We'll see you in the next one. Peace. What's going on, guys? Welcome back. Hope you are doing well. In this video, we're going to be going over how to introduce a service class into our application. And we're going to be talking about why that's important and why it's going to be beneficial for us to do things and architect our code in this way. So just to do a quick recap, all of our code that is responsible for communicating with our API currently exists inside of our view model. So what we're going to be doing in this video is refactoring our code, or extracting all of that networking related code into a service class. And I just have a quick presentation for you guys for us to talk about why that's going to be beneficial and the problems that it helps us solve. So we can see here that a service class is often used to encapsulate and manage specific functionality or data related operations, meaning fetching stuff from an API or a database. So when we create this separation of concerns, or this modularity here, it helps keep our code very organized, maintainable, and testable. So let's go ahead and break down the purpose of having a service class implemented in our view models, guys. So first off, it creates a separation of concern. So what exactly is that? So with the MVVM architecture, that already promotes a separation of concerns between different components, the views, the view models, and the models, right? But we're taking that a step further here by implementing a service class that we're going to implement inside of our view model. So we can see here that the view model is responsible for managing the UI-related logic and state, business logic and implementation, as well as data manipulation, right? And our service class is going to be responsible for handling the communication with data sources, such as databases or APIs, and it's going to supply that information to the view model. The view model will then take that data and figure out how to give it to the view. This separation makes the code base cleaner and easier to understand. So next up, guys, we have testability. And testing is an extremely important component of software engineering. You want to write code that is easy to test, and code that is easy to test is oftentimes also well-written code. And testability is important because we want to make sure everything works, especially when we make changes to it and stuff, right? So service classes can be unit tested independently of the view model and UI components. This makes it easier to write focus tests for specific functionalities without needing to deal with the complexities of all our UI components. So the more modular we make our code, the more we can test those individual modules and write clean, robust code here, guys. So testing business logic and data operations in isolation helps catch bugs early in the development process. So this modularity and testability sort of goes hand in hand here. So that brings me to my next point in modularity. So service classes promote more modularity by encapsulating specific functionalities, much like the MVVM architecture already does. So this modular approach makes it simpler to swap out or update individual components without affecting the rest of the application. So imagine, guys, something changes in our API, or we need to switch to a new API, or we change how data is fetched from our API. We don't have to go and manipulate a bunch of view models and mess up our code in all of those places. We just go to the service files or the service classes, make our changes there, and then everything else can remain untouched, right? So this modular code base that we're going to create is going to make our code a lot easier to maintain, scale, test, and modify. And then next point, maintainability. As your application grows, having a service layer between your view model and the data sources can make it easier to manage and update your code base. Changes to the data operations can be confined to the service class, reducing the impact on other parts of the app. You also have cleaner code that pretty much just relates to everything I just said. We're offloading responsibility from the view model to a service, and that just leads to simpler and more readable view model code. In summary, guys, the purpose of having a service class in a view model is to create a clear separation of concerns between UI-related logic and data-related operations. This separation enhances reusability, testability, modularity, and the maintainability of your code base, contributing to a more organized and efficient development process, guys. So this is how the pros do it, and that's what I'm trying to teach you guys here. So when you walk into an interview, you're going to have the swagger you need to write the code at the level that you need to write it at, right? With the way it's supposed to be written, the way it's supposed to be architected, to really blow your interviewers away. And it's going to overall just lead to you writing cleaner code yourselves and building more modular, testable projects. So now that we've gone through this presentation, guys, of why this is important, let's go ahead and get into the implementation in our own project and see how this is going to work. So guys, with Xcode opened up here, let's go ahead and just take a look at our coin view model class. So as you can see here, we have a bunch of code that is responsible for reaching out to our API and fetching information. What we're going to be doing now is extracting all of this code into a service, and then going over how we can implement that service inside of our view model in order to get the data that we need to update our user interface. So we're going to go into our folder for all coins here, and we're going to create a new group, and this is going to be for our service. And we are going to go ahead and create a new file. It's going to be a Swift file, and we're going to call this coin data service, guys. So we're going to make a class called coin data service. And what we want to do is go into this view model here and see if we can just extract this entire function. So let's go ahead and just copy and paste this over to our service. Okay, so now, guys, we notice that we don't have access to like these properties that are going to be responsible for updating our UI right now. We need to do this in a slightly different way. So basically, let's just go ahead and comment these lines out for now. And we need to comment these two out as well, because we no longer have these properties that are linked to our UI. So we can already see here this concept of modularity coming into play, right? We want to separate the concern of fetching information from an API and how we use that information to update our UI. So here we just want to get the data, and then the service is going to be implemented in a view model, and we're going to use the data we get back from this API call inside of the view model. So guys, the question is really going to be, how do we do that, right? Like, how do I get the information I get back from this function over to my view model? Well, your previous understanding might be, or your first guess might be to jump to returning a value, right? So we maybe want to like return a string that represents this price here. We already have access to the coin, so we're really just trying to fetch the price for this particular coin. But unfortunately for us, that's not the way completion handlers work, right? So here we get all the data that we need inside of this big block. We can't just go here and say return price, right? The only way we can return something from this function is going to be if we do it outside of that completion block. And the reason for that is, guys, is because if you remember, this code executes asynchronously. So we need a way of getting the data that we fetch from our this function here in our service over to our view model. So what we're going to do is introduce a completion handler of our own. So I'm going to go up here and say completion inside the input parameters of my function, and I'm going to say I want to get back an escaping. Let's make it a double. And it's going to return void in this block. So this is essentially how we create our own custom completion handler, guys. So let me remove this return string function. We don't need that. So basically, we just implemented one of these on our own here, and we're going to see exactly what this looks like when we call this function from our view model. So I want us to come back to this in a little bit. Let's just go ahead and see if we can implement this service inside of our view model. So now, guys, we can actually just go ahead and delete all of this code here inside of fetch price for the coin, but keep the function itself, okay? And let's go ahead and maybe just delete this now for now as well. And we are going to create a service here. So I'm going to say private let service equal coin data service, right? So we're initializing our service class inside of our view model here. And now we can use this service to fetch the data that we need. So inside of our fetch price function inside of our view model, let's go ahead and implement that function we just called or created in our service. So we're going to say service.fetch price for that coin. And you guys are going to notice it gives us two input parameters here. We can pass along this coin that we're fetching the price for. So I can just say coin. And then you guys are going to notice that I get a completion handler back here, right? So, and it's exactly the way we wrote it. It's going to give us back a double value. So if I tab over to that and hit enter now, you guys will notice that I get access to this double property inside of this block here. So now I can just call this maybe like, we can call it price from service. And this is just to be really specific with our naming here, guys. I would normally just call this like price or result or something like that. But just to indicate to you that this is data coming back from the service, we are going to name it that. So let's just go ahead and print it out. Debug price from service is price from service. So now, same thing we did before. Let's go ahead and say fetch price for our Bitcoin. And this is a pretty simple example of a refactor here, guys. So we've accomplished a main part of our goal here already, right? So our view model is now significantly cleaner, and we have extracted that code that's responsible for fetching our data from our API to this service class, and now we're just implementing that inside of our view model. So all that nasty API code that we have and all of the data parsing we needed to do and manipulation is happening in the service file. And then this is now giving the data we need back to our view model. And we're actually not going to get the data we need back just yet. I want us to run this code and show you guys that it's not going to give us anything back just yet. And you see here that we get blank on our screen and we get no print statements back. So why is that? So let's go ahead and add some print statements here just to make this concept more clear. So we're going to say print debug price in service is price. And let's go ahead and run this again. So you guys notice that I have the price in my service class, right? But I need to get it over to the view model somehow. And we're going to do that through use of this completion. So I have the price, it's represented as a double value. So now I just need to call my completion handler, guys. So I can say completion price. And then if I run my code again, let's go ahead and see what kind of print statements we get back. And you guys are going to notice something really interesting here. So we see that the price in the service, which is the print statement we added here in our service class, is 26129. And then the price from the service is 26129. So this means we've successfully passed this price information from our service to our view model, right? Because if you guys remember, we added this print statement here, price from service is the price that we're getting back from that service, which is a part of this completion handler. So this just gives you guys an insight as to how completion handlers work. They allow us to pass things from one component to another in our code. And this is unique because, you know, this is coming back as a callback from an API. So there's no guarantee when we're going to get it back. We have to make sure that we structure our code in such a way that we know we have the price before we execute this completion, and then it'll be available in our view model. So here we know that we've done all this work to get the price. We know that we've handled all of our errors, checked our HTTP responses, parsed our data, got the price, and then, okay, now we can execute our completion handler with that price. And if it's there, it's going to go ahead and give that to our view model, which is really, really nice. And just to wrap this video up, guys, I want to clean this up a little bit more. We don't need to execute this stuff on the main thread anymore. All of this can be done on our background thread. And then when we give the price over to the view model, we can just handle hopping back on the main thread from the view model. That's a little bit better in terms of our implementation here. So we can just go ahead and cut all of this stuff, replace this block here, and go back to our view model. And we can say self.price equals price, and self.coin is obviously just going to be equal to the coin that we are passing in here, right? But now what we're going to do here, guys, is cut this and say dispatch q.main.async and paste those guys in there. So here, this is a much cleaner implementation, right? We're hopping back on the main thread only when we have the data back that we need from our service, and we're updating this stuff. We need to say price from service, my bad. And we're only going to update the UI once we've done all the work we need to do on our background threads, and then go ahead and just give it to our data here. So we actually need to just parse this as a string really quickly. So we can just do some interpolation, just like that. And maybe add a $sign in front of it. And let's go ahead and run this again just to make sure it works, guys. And you can see that that is looking absolutely amazing right there, right? So that is going to wrap it up for this video, guys. I just wanted to show you how we can introduce this new architecture where we extract all of our networking layer into a service class. And this is going to be the foundation for how we set up the rest of our code that involves any sort of networking with reaching out to our API to fetch data. And this is what's considered best practices, right? And all for the reasons that we went over in the beginning of this video. We want modularity, we want testability, we want clean code, and this is how we do that. So in the next video, guys, we are actually going to be getting started with implementing this nice big coin list and continuing forward with our networking layer here and everything that's going to be involved with that. So get excited. We'll see you there. Peace.
What's going on, guys? Welcome back. Hope you are doing well. In our last video, we went over how to extract all of our API specific code or all of our networking code into a service class and then implement that inside of our view model. So it was a really nice refactor. We separated our concerns and our view model is way cleaner and our overall project is now way cleaner. So what I want us to do in this video is keep building off of that architecture and go over how we can start to fetch all of these coins here and introduce some more advanced error handling and some more advanced like JSON parsing and decoding and stuff before we get into all of our async await functionality. So I'm just going to pull up the API documentation one more time, guys, and we're going to be reaching out to a different endpoint to fetch all of this stuff. So once again, make sure you go over to coingecko.com and hit the API docs. We're going to go to this coins section and we're going to go to coins/markets. So I want you guys to just hit try it out, and we're going to see all of the parameters that we need to pass in here to get our data back in this way. So you have to pass in the currency that you want. So we are going to be looking at US dollars, but you guys could go euros, Japanese yen, whatever you want. We don't need IDs or category. We are going to be fetching this in a sort order of market cap descending. So that's going to give us back the coins in this order, right? The coins with the biggest market cap first, and then go all the way down. So you guys could do it another way if you want. Here's all the different options that are available to you. I'm just fetching 3 coins for now, so we can sort of just get an idea of what this JSON looks like. You can fetch up to 100. And this is going to help us paginate our data a little bit later on. So for now, we're just going to fetch 3. Page integer is going to be 1. This guy is going to be false. If you want, we can get the price change percentage. So this will give us back the price change over the last 24 hours in a percentage value. And then we're definitely going to want English, or at least I do, for our locale. So that's how all of our information is going to come back. It's going to come back in English. And then if you guys just go ahead and hit execute, once again, this amazing API is going to give us the URL endpoint that we need to reach out to with all of those parameters that we need to pass in. And this is the response body that we're going to get back. So you guys can see here, I'm getting back Bitcoin. It's coming back to me inside of an array. So I have an array of 3 coins here. Here's Ethereum and all of the data associated with Ethereum. And then, Tether, this guy right here. So this is just to get an idea of what our JSON body is going to look like, guys. So I want us to go ahead and implement a function to fetch all of these coins using this request URL that we have here, and see if we can get that data into our view model. And then we're going to go over how we can start to parse all of this stuff, because this is obviously way more data and information than we got back from just fetching the price of a single coin. So this process is going to be a lot different than what we did there. And we're going to see how we can get through all of this stuff and do it the right way, do it the professional way. So let's just go ahead and copy and paste this request URL, guys. Move this guy over, and we're going to go back to our coin data service. And we're going to create a function here called fetch coins. And guys, we need to, later on, we're going to, pass all of the information we get here over to our view model. But for now, we just want to see if we can fetch this stuff successfully. So we're going to have our URL string. So let's see if we can make that first off. And this one is like really long, right? And we'll clean this up a little bit later. For now, let's just leave that as is. We could even put this outside of the function if we want and make it private. I actually prefer to do it this way. And that's because we won't expose this URL string to any other components. It's private to this particular class. And now we can use it in any other function that we need. So then let's go ahead and construct our URL, guys. Very similar to what we did with our price function. We're just using a different endpoint. URL string, else return. And then we are just going to use our URL session.shared.data task with completion handler. And we're going to pass in that URL, hit enter on that block, and we're going to take a look at the data, the response.
oops, and the error. And let's just go ahead and see if we can get the data and print it out, guys. So I'm going to just go ahead and say guard let data equal data else return. And we are going to get into how to handle our error and response stuff with all this in a little bit. I just want to see if we're getting this data back for now. And let's go ahead and see if we can just print it out as a string. So we can say let data as string equal string. And you guys are going to notice we can build a string from the data that we get back, pass in the data. And for the encoding, we're going to say .utf8. And then let's just go ahead and say print debug coin data as string. So now, guys, let's go ahead and see if we can just call this function in our view model. So we're going to go here, and I am going to replace this, or just add a function rather, fetch coins, service.fetch coins. And let's replace this with fetch coins. And run our code. Ooh, build failed. I spelled data wrong. Let's run our code and see if we get back all of that nice crypto data. Ooh, and guess what we forgot to do? We forgot to say .resume. So this is, once again, that super annoying thing that we have to do with URL sessions. We are going to refactor our code in a little bit, guys, to make sure that we never forget to do that. But that's going to come a little bit later on. And lucky for us, when we get into the async await stuff, we don't have to do that. So let's go ahead and run this again. And you guys are going to notice that we get back this like big, ugly string of data, right? It's coming back to us in an array, which is good. That's what these square brackets denote. That means we are getting back a list of coins, and it's limited to 3 currently, right? So if you guys go and sort of dig through this URL string, we have the per page is equal to 3. If I change that to like 20 and run my code again, you guys are going to notice I get back 20 coins. And this is just a massive list of data, right? So this brings me to my next point, guys. You guys notice down here that we sort of manually parsed all of this information. And that's just something that's not going to be feasible here, right? So like, there's a significant amount of parameters that we are going to have to work with for all of these coins, right? We got the ID, the symbol, the name, the image, market cap, current price. So if we wanted to get all of that data back, we would have to do the same thing we did here, where we cast it as a dictionary, and then we look at each individual value associated with each individual key in the dictionary. And that's just going to be really, really, really messy. So lucky for us, Swift has a way to make our lives a lot easier, where they do all of the hard work for us underneath the hood, so to speak. So basically, guys, what we're going to do is make an object that is going to represent this coin. And within that object, we're going to use something called the decodable protocol to parse through all of this JSON data for us and set up our coin object. So if you guys are unfamiliar with object-oriented programming and what the heck I'm talking about right now, once again, I highly advise you to go and check out our Swift Fundamentals course, where we do a deeper dive into object-oriented programming and the benefits of it before you go any further with this. But if you guys are okay and comfortable with things like structs and classes, we're going to be okay here. So what we're going to do is go to our model folder, guys, and we are going to make a Swift file. And we're just going to call this coin. And we're going to make a struct here called coin. And it is going to conform to the codable protocol. And basically, guys, what we want to do is make all of the properties here that we care about, that we want to use in our view model, or sorry, our overall data here that we're going to be displaying. So right now, all we have is like the coin name, the coin image, the market cap, and the coin abbreviation here, right? But you guys might want to add things like prices and stuff like that. So I'm just going to go ahead and show you what the coin model is going to look like here. So we're going to have an ID, which is a string, a symbol, which is a string, and a name, which is a string, current price, which is a double, market cap rank, which is an int, and that's going to do it for now. So we can, oops, no comma there, that's my bad. We can add more properties as you guys see fit. And something that's interesting to note here, guys, is we don't have to use every single property that we're getting back from this list. We can pick and choose which ones we want to build our coin object here. And this is just what we're picking for now, right? So we have ID, symbol, name, and then somewhere in here you'll find current price, and somewhere in here you'll find market cap rank. For now, I actually want us to comment these two things out. We will come back to these in a little bit. What I want us to do now is just go back to our coin data service and see if we can construct our coins here using the JSON decoder that Swift gives us for free. So make sure you guys just have ID, symbol, and name, and make sure they are all spelled correctly or this is going to fail. So let's go back to this guy here and let's see if we can parse this JSON into our coin object. So we don't need the data as the string anymore. We guys are just going to now say let coins equal JSON decoder dot decode, and it's going to ask us for the type we want it to decode all of that data into. So we want an array of coins, right? So we're going to go here and say square bracket coin, and then you have to say dot self from this data. And you guys are going to notice we get a little error here. It says call can throw, but it's not marked with try. We are going to go in depth into do, catch, and try statements when we get into async await. Just go ahead here and add this try keyword. So basically this is just saying, hey, I'm going to try to decode this stuff. And then now let's go ahead and say print debug coins decoded coins. And let's see. So I think we might need to actually wrap this inside of a do catch block, or we could just add an optional try. And let's go ahead and make this a guard statement. So like I said, guys, if this try stuff is confusing, don't worry. We are going to do an in-depth breakdown of do, try, and catch statements to make this make more sense. But essentially, just understand that anytime you see try, it is going to say, hey, I'm going to try to do this, but something might go wrong. And that's why we are using an optional try, and we're using a guard statement to make sure that this works. And here inside of this, guys, we could just say print debug failed to decode coins, return. So if this decode process fails, we're going to get this print statement. If it succeeds, we are going to get back the coins that we have just decoded into our object. And I'm going to break that down a little further as well. Let's just go ahead and run our code one more time and see if this works. Okay, guys, so check that out. We have successfully decoded all of that data, and it constructs that coin object for us. So let me just dive a little deeper into that for those of you who might not understand what the decodable protocol is. Basically, guys, it's doing this process for us underneath the hood, right? So it's serializing that JSON object, and it's taking all of the keys and the values that it comes back from this JSON data, and it's mapping it into this object here. So we only care about ID, symbol, and name. And it's just basically taking the JSON data that we get back and creating coins for us. And that's because we are decoding it as an array of coins here. So if you guys accidentally, didn't add those brackets or deleted it, you guys are going to notice that this decode fails. And yep, failed to decode coins. And that's because the JSON body came back as an array of data, and you're just trying to decode it into a single coin. So that's not going to work. So we'll do a deeper dive, like I said, into do, catch, and try statements a little later on in the course. I just want us to focus on how to
solve the problem of mapping all of that, the massive JSON, into an actual object for us to use. So now let's see how we can actually use that, guys. Let's imagine I wanted to just loop through these coins and print out some data about each one. So I could say for coin in coins, print coin. Let's actually do a debug. Coin ID is coin dot ID. So this is sort of the beauty of utilizing objects, guys. And this almost always goes hand in hand with networking, right? So let's see. Check that out. So we get the coin ID of each one of the coins we got back from our JSON. So the beautiful thing about using data objects is that we can now access all of the properties we care about through this dot notation, right? So we've taken all that raw JSON data, mapped it into an object that we can represent programmatically, and now I can say coin.id, coin.name, right? All of that good stuff. Let me remove this print statement so you guys can see how that looks. And you guys notice that now I have the coin name, right? I could change this to coin name instead. Right? So this is beautiful, right? This makes our data significantly easier to work with, and it makes it significantly easier for us to pass this information along to our view model. We're not just passing a bunch of random strings like we were here and doing all of this parsing ourselves. Now we can just pass this list of coin objects over to our view model so that we can ultimately display this in a list using SwiftUI, guys. So let's go ahead and see if we can do that now. And that's going to wrap it up for this video. In the next one, we were going to get more into like error handling and some additional stuff that we need before we can hop into the async await stuff. So let's go ahead and just create a completion here, guys. And it's going to be at escaping void, just like that. So after escaping, add 2 parentheses, arrow, void. And this is how we build a completion handler. And what do we want to give our view model? We want to give it an array of coins, right? So we're just going to go here and say completion with this array of coins. And then we can say completion coins, just like that. So now if we go back to our view model, we're going to get an error here because we have added a completion handler to this function. So just go ahead and delete that and say service.fetchCoins. And now you guys are going to notice that this completion handler gives us back an array of coins. So if I hit enter on it, guess what? Now I have access to the coins that I have fetched in my service. So I can say coins, and then let's just go ahead and say print. Let's actually add that print statement back in our view model. For coin in coins, print debug coin in view model is coin dot name. And let's go ahead and run this, guys, and see if that works. And check that out. We are successfully passing this data over through that completion handler from our service to our view model. So this is looking really, really, really good. Now, what I want us to do next is actually get this data showing up inside of our view. So basically, guys, we can delete all of these properties here, and I'm going to create a publish property for an array of coins. It's going to be an empty array. And here we can just go ahead and say self.coins equals coins. So now this is being published. And because we are updating our UI, guys, let's actually just go ahead and delete this fetch price function. We don't need that anymore. We need to make sure we're doing this on the main thread. So let's go ahead and say dispatch queue.main.async self.coins equals coins. Beautiful. Now let's just go over and see if we can build a quick list to display these coins, guys. So back in our, content view, we are going to replace this VStack here with a list, and we're going to say for each viewModel.coins coin in. And let's just go ahead and see if we can say text coin.name. All right. Let's see what is going wrong here.
Okay, so coin needs to conform to identifiable. So let's go over to our coin guy. Lucky for us, we get an ID property already from our JSON. So we can go here and say identifiable. And now we conform to the identifiable protocol, so we can loop through this stuff using SwiftUI to display the information. So now guys, let's go ahead and run this code, and we should see a list of coins showing up. And check that out. That is looking absolutely incredible, right? This is information that is coming back from our API. We're using a service to fetch that. We're handing it over to the view model. The view model is publishing those changes and updating that coins array. And now we have it over in our view. So really quickly, guys, just to do a quick recap on that architecture, the service is responsible for fetching the information from the API, and the service gives this to the view model. The view model receives that information from the service through this completion block or completion handler, and then we hop back on the main thread because we had to initialize that fetch on a background thread, and we say, hey, the coins here is going to be equal to the coins we get back from the service. So once again, this keeps our code super modular, makes it easy to test, and keeps our code really clean as well. And we set this coins array, we publish that change, our view receives that update, loops through all of the data that we get back from our view model, and displays it in a list. So that's the foundation of how the MVVM architecture works, guys, using services and completion handlers. So this is all really coming together and looking really good. What I want us to do in the next video is go over how to implement some more concrete and more robust error handling so that if things go wrong, we can display that information to both the users and the developers working on the code. And then we're going to go over how to make our service a little bit more generic. And then we are going to go and get started with refactoring all of this stuff using async await. And this is really coming together, guys. This is giving you a really good insight as to how the pros create code to network and contact and communicate with APIs. I hope you guys are enjoying this so far. We'll see you in the next one. Thanks for watching. Peace out. What's going on, guys? Welcome back. Hope you are doing well. In our last video, we went over how to fetch all of these coins and display them in a list. So we're going to be continuing on with this. We're going to get into some more in-depth error handling in this video. And we're also going to be modifying our coin object struct a little bit to start things off. So if you guys go back to the model object, you'll notice that we only have 3 properties for our coin. We have the ID, the symbol, and the name. We commented out current price and market cap rank. So I want you guys to go ahead and uncomment these things and go ahead and run your code and see what happens. You guys are going to notice that we're not going to get any information back inside of our view. And you're going to see here that we got this handy little error message that said failed to decode coins. So why is that, guys? So during the decoding process, something is going wrong and we need to try to figure out what that is. So if you guys bring back up your API documentation, you'll see things like the market cap rank is separated by these underscores, right? And so is market cap, so is current price. So pretty much any property that is more than one word is separated by an underscore. But you guys notice ID, symbol, and name are good to go. So just a quick recap on how the decodable protocol works. It looks for these keys and assigns the associated value to the property in your data object. So because we spelled ID, symbol, and name the exact same way it appears in the JSON body, it assigns these properties the values that are associated with those keys. But it's very important to understand that the spelling and the casing as far as uppercase and lowercase has to match up directly. So guys, if you were to change this to current underscore price and market cap underscore rank and have those all be lowercase, I believe this would solve those issues and give us back the data that we want, right? So yeah, that looks good. And that's because now these things match up exactly in terms of the spelling and the casing and the underscores with how it appears in the JSON body. But oftentimes in our code, we don't want properties to look like this, right? This is what's known as snake casing. We prefer camel casing as programmers. And camel casing is that concept of the first word being lowercase and each subsequent word in the parameter name being uppercased. So how do we accomplish this given that we have a mismatch in the keys that are coming back from our JSON body and the keys that we have inside of our struct. So the decodable protocol has a fix for that, guys. We're going to go ahead here and create this enum called coding keys. So this is an enum that we can use to specify the exact spelling of our coding keys and assign the properties values based on what's coming back from our JSON body. So we're going to say string coding key. Make sure you guys say coding key and not coding keys here. And we're just going to say case ID, comma, symbol, comma, name. We don't have to assign these like a raw value because they match up directly with what's coming back. But this is where it gets interesting. So we're going to say case current price equals current underscore price. So guys, basically this is going to take our current price property and say, hey, this is what the value, or sorry, the key is going to look like in the JSON body. Go and find this, find the value and assign it to this current price guy. And now we can use this how we want to with that sort of camel casing there. And we're going to do the same thing for market cap rank. Case market cap rank equals market underscore cap underscore rank. And guys, that should be all we need to do. Now you guys should notice that if we were to run our code again, that we are going to get back all of our coins and everything is going to be looking good, right? And that's because we set up this coding keys enum, and you guys could do that for any other property you want. This is something that happens commonly with when you're working with APIs, guys. Oftentimes the stuff won't come back the exact way you want it to, so you have to implement some sort of structure here to decode the things the way you want it to, right? And use the keys the way they come back from the JSON data or the database or the server, the API, whatever it is, to map it to the correct name. So now that we've done that, guys, let's go ahead and see if we can make our UI look a little bit more like this. Let's see if we can utilize some of those new properties that we have, mainly just the market cap rank here. We're also going to add another property later on for the image, but like I said, that will come later. We have to go over how to fetch and download images and all of that good stuff. That's going to come later in the course. So let's go back to our content view, and instead of just text coin.name, let's make an HStack. And we're going to start this with the coin.marketCapRank, or sorry, that needs to be in a text property. Text, and we need to make this a string, coin.marketCapRank, and you guys notice that now we have access to that property the exact way that we spelled it out with our camel casing, which is nice. And we're going to say .foreground color of .gray here, guys. And then next to that, we're going to create a VStack. The alignment is going to be .leading, and we're going to say text coin.name and text coin.symbol. And then we're going to make the whole font on this .footnote. And we're actually going to bold this guy. So we're going to say .font weight is .semi-bold. So guys, let's go ahead and run our code again and see if our UI is coming to life a little bit, just to, spice this up a little bit and make it look nicer. So yeah, that's not looking too bad, right? We do want to capitalize the guy right here. So we can just go here and say coin.symbol.uppercase, and let's give our VStack a little bit of spacing. I'm thinking maybe 4 pixels, right? So let's go ahead and run this again. And okay, not looking bad. Let's give the HStack a little bit of spacing as well, maybe 12 pixels, and run this one more time. And that should be it for the little UI updates we want to make, right? And later on, guys, like I said, we're going to add all of our coin images and all of that good stuff. But this is looking really good so far, right? All of this information is coming back from our API, and we're displaying it in a list. And the scrolling is really smooth, and everything is looking great. So next up, guys, I want us to get into part 2 of this video, where we're going to be getting into some more in-depth error handling. So let's hop back over to our coin data service and take a look at what we have with this fetch coins function. So right now, we're literally handling 0 error, right? We have this print statement here if our decode were to fail, but that's not really good enough, right? Like if you guys were writing this for like a job, or you're writing this in your own application, this is the lazy way of doing things. You're just going to say, hey, I'm trying to fetch this data. I don't really care if anything goes wrong. I just want to get data showing up on the screen, which is okay for like just building little mock and practice projects. But when you're building something that's going to go into a production, like an app to the App Store, or you're working for a company, or you're doing a coding interview, you really want to make sure that you dive deep into the depths of error handling, because it's going to save you a lot of time in the long run. And as an interviewer, they want to know that that's the way you code, right? So that if you write code, they know you're going to handle your errors correctly, so that if anyone else comes and looks into your code, they're going to say, okay, hey, I know exactly what's going wrong, when and where it's going wrong. That makes the code a lot easier to work with. So let's go ahead and see how we can start introducing some more in-depth error handling here, guys. So basically, we're going to want to adjust this completion handler. So we're going to want to say, hey, if anything goes wrong, let's execute a completion with an error as well. So in this escaping guy, we are going to go outside of that bracket, the square bracket, and we're going to add an optional error right here. So now one of two things could happen. We could get back an array of coins, or we could get back an error, much like we see here with the stuff that we get back in our completion handler, right? We could get back some data, a response, or an error. So let's go ahead and start this off by handling our error here. Let's comment this line of code out really quickly. So right above the data guard let statement, let's go ahead and say if let error equals error. We can just say completion nil error, just like this. So what we can do is make this guy optional as well, right? Because we may or may not get this back. So basically, if an error happens, we don't get this back. If we get this back, no error happens, right? So we have to make both of these things optional. And then we can just go here and say return. And then guys, if we are good to go, we'll say completion coins, comma nil. So this introduces a small level of error handling, right? Which is a really, really good start. So let's go back to our coins view model and see what that's going to look like now. So you guys are going to notice that we have to update our completion handler here. So I need to say coins error in, and even if I try to build this now, this coins guy is coming back as optional. So we need to make sure that coins is there before we try to use it, right? So I could give it a default value, right? And just say, hey, if there's no coins guy here, just give it a default value of a blank array. That's totally fine. But now let's see if we can get into more of what we want to do with this error, right? So once again, we could add that error message, published var error message, which is an optional string. And we can say if let error equals error, self.error message equals error dot localized description. And then we can just go here and say return, because we don't even want to bother going to this line of code, right? If there is an error. So we're doing all of this on the main thread, which looks good. Now guys, we could go back and update our UI once again. And basically all we need to do is say that, hey, if there's an error message, let's show that instead of this list. So there's a couple different ways of doing this. You could wrap this whole thing in a Z stack and do it that way, or you could just give this an overlay. What we're gonna do a little later on is actually introduce alert components into this. So it'll display an alert message to the user instead of just this error message, and maybe give them to option to retry the fetch and all of that stuff. So basically guys, we can just say if let error equals viewModel.error message, we can just say text error, right? And to simulate this error, let's just go back to our coin data service and go to this URL string and maybe say, hey, let's delete that I from the API, and just to make the URL invalid. And you can see here that we're getting our error message coming back. So that's looking pretty good, right? This gives us a way of passing along an error in our completion handler, and we're making this as safe as we can by making both of these properties optional. However, this isn't the best way of doing things, guys. And why is that? It's because dealing with these two optional parameters gets pretty messy, and you have to use, an optional execution of your completion where one of the components is nil and one of them is not. And it's just not super robust, right? And lucky for us, Swift has a data type that allows us to make sure we handle success and failure cases when working with completions. So I want us to go over how to introduce that next. So basically, guys, we can let's just copy and paste this function. I'm going to keep all this stuff here for you guys so you can see the different ways of doing things. And let's go and call this fetch coins with result. And basically, guys, what we're going to do is replace this coin and error with this result type. So you can see here that a value that represents either a success or a failure, including an associated value in each case. So basically, this is going to allow us to say, hey, if there's a success, complete with a whatever data type you want, and if there's a failure, complete with some sort of error. So we're going to go here and say our success case is going to be an optional set of coins, and we're going to use this opening caret bracket like that, guys, to do this, and then we're going to say error right here. So you guys will notice that because we're using this result type now, we don't actually have to make either of these properties optional. We're completing with this result here, and we're going to see how we can work with that in just a second. Let's actually do that now. So instead of saying completion, nil, and error, we can actually say, hey, completion, and you're going to be able to say dot failure and just pass in that error right there. So we get this dot notation, right? And if you guys want to command click into that, basically we can either get a success or a failure. And then down here, we're going to see the success case. We're going to say dot success, and we're going to pass in those coins. So you guys notice that when I do say dot success, it recognizes that my result type wants a array of coins when we are successful here, and it wants an error type when we're not. So we can just go ahead here and pass in our coins. And now, guys, this is a significantly more like robust function for our completion handler here, right? Because we're working with this result type, and we have to handle our two potential cases for when something goes wrong or something goes right. Whereas here, this wasn't as concrete, right? We're working with optional data. There's no guarantee that we got a success or a failure. It's all up to us as the programmer to execute it in that way. Whereas now here, we're working with this concrete result type, and that result type can only have one of two potential states, a failure or a success, and then we pass along the associated values or data when either of those cases happen. In the failure case, it's an error, which is this guy right here. In the success case, it's this array of coins, which we have right here. So now let's go ahead and see how we can utilize this in our view model and why it's going to look better and overall be better than the previous way of doing it. So I'm going to go ahead here, guys, and say, let's just remove this stuff or comment it out. So I'm going to say service.fetch coins with result. And now you guys are going to notice my completion type is a result. So I'm going to say result in, and now we are going to be able to do a switch over the result that we get back. So if you guys select this option in your autocomplete window and hit enter, it's going to fill this out for you. So this result type is essentially an enum, guys, and it's going to switch over the only two potential cases that we could have on this result. So when we have a success, we know that we have coins. When we have an error or a failure, we know that we have an error data type. So here, now we can say self.coins equals coins. And here we can say self.error message equals error dot localized description. So now, guys, let's go ahead and run this. And we should notice that everything works exactly the same. But like I said, this is a significantly better architecture and a significantly better way of doing this stuff. So it looks like we are on the main background thread still. So let's just go here, guys, and say dispatch queue.main.async and paste that in there. And let's go back to our service and make sure our URL is good to go, just to make sure that our success case is working as well. And we can see here that that looks absolutely beautiful, right, guys? So once again, the benefit of using this result type is it sort of forces us to handle our error situations, right? We have to look at the failure and the success case, and it just makes it a lot more robust and concrete than working with this optional sort of completion setup that we have here. So that gives you guys an insight into some more concrete and robust and professional error handling. Now that we've handled that, guys, I think I want us to start getting into how we can make our service more generic and ultimately start getting into the async await stuff. So we might actually wrap this stuff up with the completion handler stuff here. The main purpose of doing this, doing stuff with completion handlers, which is sort of considered the older way of doing things, is you guys are inevitably going to see this in the professional world, right? A lot of you guys might be wondering, hey, why didn't we just jump straight to async await? And that's because async await is pretty new, and there's no guarantee that a company that you go and work for or a code base that you hop into for whatever the reason may be is going to be up to date with the latest async await technology. So it's very important to understand how completion handlers work. And there's actually a couple more things that I want to wrap up with completion handlers before we move on to async await and continuing on with our networking bootcamp here. So that's what we're going to be doing in the next one, guys. We're going to wrap up all this completion handler stuff, and then we are going to move on to implementing the async await functionality, dependency injections with our services, more generic services, and all of that amazing stuff. And then also fetching images and all that cool stuff as well. So get excited for that, guys. We'll see you there. Peace. What's going on, guys? Welcome back. Hope you are doing well. In this video, we are going to be introducing some more custom error handling, and we're also going to be talking about some of the problems that arise with completion handlers and how we can deal with those issues. So this custom error handling API we're going to implement is going to carry over into our async await stuff. This is going to be an integral component of handling errors in your applications, guys. We've done some introductory stuff for error handling, but we definitely want some more custom functionality here to get more in-depth descriptions of what's going on if things go wrong during our networking process. And then to end this video and to end the completion handler module, really, we're going to cover some things that we need to watch out for with completion handlers. So to start this off, guys, let's not waste any time. Let's go to our model folder, and we're going to create a Swift file, and we're going to call this coin API error. So this is an enumeration we're going to create to handle all of the different potential error situations that we could run into. So we're just going to create an enum called coin API error, which is an error. And it's going to inherit from the error type. And we're just going to introduce a couple different scenarios, guys, or cases for what could go wrong when we are networking. So first off, we're going to have a case for invalid data. We're going to have a case for JSON parsing failure. And then we are going to have a case for our request failing. So request failed. And we're going to add an associated value here, which is going to be a description. And then, guys, we are going to say case invalid status code, and we are going to pass in a status code here, which is going to be an integer. So this will happen if we get back like any sort of 404 errors or anything like that. We're going to have an invalid status code, and we just pass that along into this enum case. And then we're going to have another case for unknown error. And we are just going to pass along a generic error here. So if anything goes wrong that wasn't covered by this stuff, we can just pass along in an unknown error. So now, guys, what I want us to do is introduce this custom description. And we are going to do a switch statement through this to go through each one of these individual cases and add our own customized description to this. So first off, for invalid data, we need to say switch self. We can just say return invalid data. Pretty straightforward. And this gets a little more interesting. Let's do the JSON parsing guy first. So we can say case.json parsing failure, return failed to parse JSON. And then for the next one, guys, because we have an associated value that's coupled with this, we are going to say case let.request failed description, and that is just going to be this guy here. And we are going to say return request, failed, and pass along that description. And we're going to do the same thing for our invalid status code. Just like this, and we'll say invalid status code and pass along our status code. And then for our unknown error, guys, we're going to say case let dot unknown error, return an unknown error occurred, error.localized description. So this is going to be the foundation for our custom error handling, guys. Let's go ahead and hop back into our coin data service class just to see how we can initial or actually use this stuff. So right now our error handling is pretty simple, right? So what we can do is replace this generic error that we have here, guys, with like our coin API error. So because that inherits from the error type, it's going to be good to go. So now we can go through each one of these situations like we did down here with our HTTP response and our status code and our data parsing and all of that stuff, and really introduce this more in-depth error handling here. So first thing I want us to do is go ahead and grab these two things, the HTTP responses that we were looking at. And let's go ahead and paste this in here. And oops, not there. Paste it in here rather. And you guys will notice here that instead of just saying print or like self.error message is equal to that, now we can say completion.failure, and it's going to ask us to supply with a coin API failure. And this guy is going to correspond to a failed response. So now you guys will notice that I'll be able to say request failed here, right? And we can just print like request failed. And next up, we can go ahead and use our status code message here, right? So I can go here and say completion.failure, and we could say .invalid status code. And I can now pass in my HTTP response.status code, right? Cool, cool, cool. And guys, here, if the data is bad, then you might have been able to guess it. I can just go and say completion.failure.invalid data and return there. And then if this goes wrong, I could introduce my JSON parsing error, but I actually want us to introduce a do catch here. So you guys remember we had this try statement. Anytime you have a try statement, you can introduce a do catch block, and I'm going to explain that briefly here. So go ahead and say do and then catch. So we are going to say let coins. So just go ahead and copy and paste this. Let coins all the way before the else keyword and paste it in there like this. And we're going to remove that optional try. And then we are going to say catch. Oh, and guys, we need to go here and say completion.successCoins in the do block. And guys, what happens in the catch block is when things go wrong. So in the do statement, it's going to try to execute this stuff, right? Which is why we have that try keyword here. And if something goes wrong, it's going to hit this catch block and it's going to say, hey, something went wrong during this process. And we know because we're trying to decode something that our decode would have failed. So we can just say throw, or rather we can say completion, .failure, .json parsing failure. And let's just go ahead and add a print statement here. Debug failed to decode with error. Error. And you guys will notice that we get access to an error inside of this catch block, and that's because Swift implicitly does this for us. We say catch let error, so if the error happens, we have access to it right here. Swift actually doesn't make us type that. Because we're inside of a catch block, we get access to the error with what went wrong. And the reason I'm adding a print statement here, guys, is because we, as a developer, we would want to know what went wrong with the decode, but we don't necessarily want to display that to the user, right? Because that's not going to make any sense to them. So here we could just print this out sort of privately so that we can know what's going wrong, and the user, we could just decide what we want to say to them if the JSON parsing fails. And we're going to get into the alert component in a little bit. So this is a much more robust error handling system now, right? So you guys will notice here that we have to pass in like a, sorry guys, in the if let error statement, when this error, guys, comes back to us, we can say .unknown and pass along that error here. So that looks good. If you guys heard airplanes just now, I literally think the president was just flying over my house. It looks like a bunch of military airplanes, which is pretty cool. But anyway, guys, like I was saying before, this is a much more in-depth error handling system, right? We know that we could have all of these different potential errors, and we're handling each individual thing and getting some sort of custom description along with that. So this is going to carry over into our next module with the async await stuff, guys. I just really wanted to introduce that to you here. And this is a much more, like I said, robust error handling system that you can really drag and drop into any one of your projects. This is pretty standard for all networking layers that you're going to have in your code. And you could, just go to this coin API error guy and add or remove things as you see fit. That's what's nice about utilizing this as an enumeration. So next up, guys, what I want us to cover is a potential problem that we can have with completion handlers. And this is going to tie into the concept of retain cycles. So let me just show you guys something that you are going to see used quite a bit when working with completion handlers. So in this guy right here, where we are getting back the completion from our service, you're oftentimes going to see this notation here, brackets, and you're going to have weak self inside of it. And what this is going to do is make all references that you have to self inside of this completion block. And in this case, guys, self refers to our coin view model. That's why we say self.coins. And it refers to this property here because it's contained within this class. So here self is referring to class, the coin view model. So you guys are going to notice that now I have to add optional chaining here. I have to say self.question mark. And that's because now we have created a weak reference to ourself instead of having a strong reference to ourself. And if you guys tried to remove self altogether, you would get an error and saying, hey, you're inside of a completion handler or a self-contained block of code. You need to add self here in order to clarify what you're referencing. So you always, whenever referencing like class level properties, guys, you have to say self when inside of a completion handler. And this sort of ties into the whole concept of escaping. So you guys remember here that we have this escaping keyword. Just to touch on that briefly, it's basically saying that we want this property that we are executing the completion on to be able to escape this particular block, right? So if we go back to our coin view model, this is treated as a self-contained or separate block of code. And if we want to utilize this result in any way, we need to make this an escaping closure so that we can say, hey, the properties that we're getting back inside of this block can exit this block and update things that exist outside of it. So this block is literally like its own little self-contained piece of code, guys. And now we're going to get into why we need to add weak self to this in order to be as safe as possible. And the reason for that is because if you don't, you can end up with something called a retain cycle. And I'm just going to do a brief introduction or like a brief explanation of what a retain cycle is. So I have this diagram here to help us understand this concept. So let's imagine we have these two objects, A and B, in this app we're creating. In our case, object A refers to our coins view model, and object B is referred to by this block of code that we have here. And in this situation, object A has a strong reference to object B, and object B has a strong reference back to object A. So this creates a cycle where both objects keep each other alive in memory, even when they're no longer leaded. So in programming, this situation is analogous to two people holding hands and never letting go, even when they should move on. This can lead to wasted memory and unexpected behavior in your application. So basically, guys, when we try to destroy object A, i.e. it's no longer needed, we either close out the app or we go to a different screen or whatever it may be. If we have this retain cycle here and they both have strong references to one another, they can never actually be destroyed. They're held onto in memory forever. And that's because when we destroy object A, it has a strong reference to object B, but when we try to destroy object B, it still has a strong reference back over to object A. So it ends in this infinite loop of holding on to one another, like those two people we just talked about holding hands. So let's talk about strong references really quick, weak references, and then discuss how weak self helps us solve this problem. This is an extremely important concept to understand, guys. This question gets asked in interviews all the time, and it's very important to understand when working with completion handlers and retain cycles in general. So strong references. By default, when you create a reference from one object to another in Swift, it's a strong reference. So for example, if when I'm in this completion block here, guys, and I don't have weak self, right? And I say self.coins and self.error message. This is treated as a strong reference, even though this is sort of like a child object that's part of this coins view model class, right? So right now, these are treated as strong references. So I have a reference to from A to B because this block here is contained within my object A, which is my coins class. And then I have a strong reference from object B back up to my parent class, right? When I say self here, and self refers to the coins class or object A in our diagram. And these are properties that are associated with object A. So it means that as long as any object holds a strong reference to another object, that second object won't be deallocated. So a weak reference, on the other hand, doesn't keep a strong hold on the object it refers to. If the object it refers to is deallocated elsewhere, the weak reference automatically becomes nil or gets wiped out as well. So we will never end up in a situation if we use weak references here where coins view model gets deallocated, but this block does not. And that's why we use this weak self guy, okay? And then that's why you'll notice that when I try to reference self now, I have to make it optional because it's treated as a weak reference. So in iOS development, that's what we often do. We use weak self inside closures like these completion handlers to avoid strong reference cycles. When an object like a view or a view model uses a closure, for example, to handle some asynchronous task, which is what we're doing here with fetching our data from a service, you might need to reference self inside that closure, which is what we do here because we ultimately want to take this stuff and give it and update these properties here so we can update our UI. However, using a strong reference to self in closure could create this retain cycle where both objects hold on to each other infinitely and can never be destroyed, which causes memory leaks and poor performance. So you use weak self to make a weak reference to self inside of the closure, which is what we are doing here. This means that if the closure lives longer than the object, which is possible, right? That's when this can go wrong. If this closure for some reason lives longer than our coins view model. So for example, guys, let's imagine I launch my app and let's see, where is it? Right here. Or this is my completed version, right? So here I'm fetching details for a coin, which is something we're going to introduce later on. But let's imagine that I just go to the screen and go back from it really, really fast. If the information that comes back from that API call that would get executed inside of a completion handler like this might hang around even though we've dismissed that screen. So in that situation, the block here or the closure might technically live longer than the original object or the parent object. And in that situation, that's when you get that sort of retain cycle if you don't use a weak reference to the self. So when utilizing the weak reference, whenever our parent object gets deallocated in memory, i.e. we go to a screen and then exit that screen, or we kill the application like this, right? Then that helps us to guarantee that we won't create that retain cycle. So in a nutshell, weak self is a mechanism to prevent strong reference retain cycles and memory leaks when working with closures in iOS development. So this is something that you're always going to want to do when working with completion handlers, guys. I hope that explanation makes sense. If not, there's some more information that you can look up online in regards to retain cycles in Swift. And it's just a concept that is important to understand, especially when interviewing and writing code that involves completion handlers. And retain cycles don't necessarily have to happen in completion handlers. They can happen anywhere in a project where you have things that are referencing each other, right? So it's an important concept to understand overall, and that's my breakdown of it. Hope that made sense to you guys. But, in the next module, we're thankfully not going to have to deal with closures because we're going to be utilizing async await, which is going to be so awesome. And we're going to see why this is a much better API for networking than is this previous setup with using completion handlers. But like I said, nonetheless, it is very important to understand this stuff just because it helps us understand certain concepts in coding that are very important, like these retain cycles that we see here. and is also important for things like interviewing and helps an interviewer understand that you understand these complex sort of concepts that arise in programming with networking and stuff like that. So thanks for watching this one, guys. I know that was a little bit of a long-winded explanation, but it's important. Like I said over and over again, it's an important concept to understand. In the next video, in the next module, we are going to be refactoring all of this code to utilize async await, and that's going to be a lot of fun. So we'll see you there. Peace out. What's going on, guys? Welcome back. Hope you are doing well. This module is going to be really exciting because we are going to be getting started with introducing the async await functionality that Swift has introduced. So we're just going to start this off with a brief introduction as to what it is and why it's a more modern and concise approach to asynchronous programming. So really quickly, guys, async await is simply a more modern approach to handling asynchronous operations. We saw how we could do so with the use of completion handlers, and this module is going to be all about refactoring this existing code we have to using the async await functionality, and we're going to see just how much more cleaner and concise it is than using these completion handlers. So it simplifies that whole process of asynchronous code by allowing you to write it in a more linear and synchronous style, making it a lot easier to read and reason about. With async await, you can write asynchronous code that looks similar to synchronous code without the need for nested closures or completion handlers, and it really helps us avoid that nasty concept of retain cycles here as well, because we're not going to be having to use completion blocks. So with that being said, guys, let's go ahead and start refactoring our service here to utilize the async await functionality. So what I want us to do, guys, is just remove some of this or clean some of this completion handler code up first. First off, we can delete this fetch coins function. We are doing a much better way, or implementing that in a much better way with this fetch coins with result guy. And we can keep this fetch price guy just so you guys can see the difference between our custom initializations that we did here versus the decoding that we did up here. But what I want us to do is take both of these functions. So I'm just going to go and highlight both of them and hit Command X to cut it out. And I'm going to create an extension on my coin data service and just paste them in there and add a mark here and say this is completion handler stuff. And that's just to sort of keep it out of the way. We don't want this file to get too nasty. And now I'm going to go up here and in the coin data service function, write my first asynchronous await function for you guys. So we are going to say func fetch coins. And we are going to set it up just like this. And the first thing we're going to need, guys, is to grab and create our URL here. So let's just do the same thing we did in our fetch coins with result guy. So we're going to create our URL. We ultimately still need to utilize this URL session.shared.data task, which we're going to see here in just a second. So something I want you guys to do now is go ahead and say try await URL session.shared.data, and then you're going to look at this option that says from. And you guys are going to notice that it has these interesting keywords here, async and throws, and it returns a tuple here. It's going to be a data object and a URL response. So let's go ahead and select this guy and just pass our URL in here. And we're going to get some errors here, guys. So you guys notice that async call in a function that does not support concurrency. So Swift recognizes here that we're trying to implement this async await functionality, but it says we're not inside of a function that supports that. So if you guys were to go ahead and click on this guy here and hit fix, you guys are going to notice something interesting. It adds that async keyword to our function definition up here. And then you guys are going to notice we get another error, and it says errors thrown from here are not handled. So in order to fix that, guys, we're just going to go ahead and add this throws keyword to this function here. And then those errors are going to go away, and we just get a warning back. So I just want to break down what exactly these two things mean. So basically, guys, this is how we set up a function that supports concurrency or async await functionality. So basically, we're saying that this is going to be an asynchronous function and it can throw potential errors. So this is accomplishing something very similar to what we had down here, where we were using this completion handler and we were saying that, hey, we can get a potential error back. That's what this throws keyword is going to represent. It's going to say, hey, this function is going to have the ability to throw an error or say that something went wrong in some sort of process. And the async keyword just represents that that this function is going to support Swift concurrency and asynchronous operations. And we have to do that if we want to use this try await stuff in the body of the function. So you guys are going to notice here that this is where things get interesting, right? Result of call to data from this guy right here is unused. And if you guys remember, this is actually returning something. So if you were to hold down Option on that data guy, it returns a tuple, data and response. So let's go ahead here and set that up. So we're going to say let parentheses data response and set it up as a tuple equal try await URL session.shared.data from that URL. So this is really, really cool, guys. And this is because now we can get back this data from our URL and store them in these two properties without having to utilize a completion block here. And that's because of how this try await stuff works. Basically, what this is saying is, hey, we are going to wait for the result of this API call to come back, and we're going to suspend the compilation of your code at this point right here. So this creates a suspension point in your code. So we're not going to move on to line 18 until we get a response back from this attempt to get the data from that particular URL. So here's how we can use it in the next line. We can say print debug response, and let's go ahead and print the response as an HTTP URL response, and let's say print debug data is our data. Okay, so now, guys, ultimately what we want to do is call this function inside of our view model, and we're going to see how we can do that now. Before we come back to how exactly this stuff is working and you know how we can handle potential errors and stuff like that. So let's go back to our view model, and let me delete this guy, and let me modify this function to say fetch coins with completion handler, and let's make another function to fetch our coins. And we are going to introduce something called a task, but let's do that in a second. We're just going to go here and say service.fetch coins. And you guys are going to notice that we're trying to fetch it and utilize this async throws functionality. So in order to do that, we need to say try await. So you guys notice that, hey, you're in a function call that does not support concurrency. So guys, this can start to make you ask the question, okay, how can I ever use this async await stuff in a function that doesn't support concurrency, right? Because if I add async throws here, that arrow is going to go away. But then you guys are going to notice the error just moves up to this point and it says, hey, async call in a function that does not support concurrency. So it's like we are going to keep going down this path. Eventually, we have to be able to call an asynchronous function from a non-asynchronous or non-concurrent environment, right? So we're going to do that through use of something called a task. So you guys are just going to go here and create this thing called a task, and you're going to say fetch coins like that. And because this is this function has async throws, you also need to say try await here as well. And we're going to clean this up in a little bit, guys. I just want us to get this working for now to see if we're getting those print statements back. And check that out, guys. We are getting those back without having to use a completion handler. And that's the main point that I want to hammer home here. And we're going to go back and explain this stuff in a little bit. We're getting back 17,000 bytes of data, and we get back this URL response, right? And we see the status code is 200, which means it's a successful response. So if we go, and we're going to come back to this in a little bit. Let's just go back to this coin data service really quickly. So guys, we wrote one single line of code, and we were able to utilize the data that we got back from this URL session.shared.data task, which is an asynchronous process, in sort of a linear synchronous manner. right? If you guys remember here, we had to go inside of a completion block and wait for that stuff to come back to us. And if we were to write code outside of that block and like, you know, blah, blah, blah right here, that code would execute before everything came back in this completion handler. So that was an asynchronous process that was happening, right? Even though we have code that's executing line by line, our code comes back to this point of execution after this task completes. That is different from our async await functionality in that we are going to await the result of this asynchronous process here, and we're not going to go to the next line of code until we get a result back there. So this creates what's known as a suspension point in the code, guys. So if you were to add, you know, a print statement here, print debug fetching data, you guys are going to notice that all of this stuff comes back synchronously to me or in order, right? And that is actually really, really, really cool because like I said before, it completely removes the need for us to introduce completion handlers. And it's just going to say, hey, let me just wait for this to come back and then I can use that data on the next line of code. So that brings me to my next point, guys. What happens if something goes wrong in that process, right? Like, how do we handle these errors? And this is where do, catch, and tries come in. So let's just go ahead and wrap this inside of a do and catch statement. Just like this. And we got a brief introduction to this when we were working with our JSON decoding down here. So guys, I'm going to go ahead and copy and paste this stuff up into the do block. And if something goes wrong in the catch statement, let's just go ahead and print out our error. Right? And this is how we handle errors in an asynchronous context, right? We are going to try to perform this task and we're going to wait for the result of it to come back. If at any point something goes wrong, it's going to immediately exit that point of execution in the code and jump into this catch block. So if something goes wrong, I'm not going to get these two print statements back. It's going to create the suspension point in the code, and it's going to say, hey, something went wrong. I'm going to stop execution of that right here, and I'm going to jump straight into this catch block and give you back your error. So this is the concept of throws, guys. Anything that has the throws keyword means that you have to try to do it. And if you fail, you hit this catch block. It catches the error for you, right? So now let's go ahead and run this code. But first, let's once again force our error to happen by modifying that URL. And let's see what we get back now. So check that out, guys. We got the fetching data statement, right? Because we're right here. And then it went and hit this line of code in the do block and it said, hey, an error happened. So I am not going to go and execute these two lines of code. It jumped immediately to the catch block and said a server with the specified hostname could not be found. So we've essentially done everything that we did with the completion handler stuff in a much, much cleaner fashion, right? Like this is a lot sleeker. Our code looks like it's synchronous, right? And it behaves like synchronous or sequential code where it just goes line by line. We have this new concept of a suspension point though, where we're going to wait for the result of something to come back before we try to use it on the next line of code. So what I want us to do to finish this video out, guys, before we get more into our error handling and stuff like that, is to see how we can actually get our coins back from this stuff, right? So we can take this data and do the same thing that we did with our, what's it called? Our JSON decoder. So I can literally go and copy and paste these two lines of code, or just, let's just do this guy. So let coins equal, try to decode an array of coins from that data. And now it's like, okay, how do I get this over to my view model, right? Like I have the coins, what do I now do? And guys, let's just go ahead and replace this response with an underscore for now. We'll come back to that in a little bit. So what's really nice about asynchronous code, guys, is now that we don't have to work with completion handlers and we are working in more of a synchronous fashion, even though we're executing asynchronous operations, is we can return things from it. So in this fetch coins function, I can go up here and say, hey, I want to return an array of coins. And now that I have my coins here, after I executed my API call, I can just go and say return coins. And it's literally that simple. So let's see. We need to fix this URL statement. So if our URL fails to create, we're just going to return a blank array. And let's go ahead and run this bad boy. Here, yeah, we can, in the catch block, guys, you can also just return a blank array and put your print statement before that. Okay, so let's go ahead and add our I back into our API guide just to make sure our URL is legit. And let's go ahead and run this. And you guys are going to notice nothing happens yet. But we did not get our error message, which is good. So now we can go back to our view model, guys, and let's check this out. Because this now returns an array of coins, I want us to go back here, and literally all we need to do is say self.coins equals try or wait service.fetch coins, because this guy is going to return an array of coins to me. So guys, this is going to create, once again, that suspension point in our code. It's just going to say, hey, try to do this and wait for it to come back. And whenever it does, store it in this property, or make self.coins equal to that guy right there. And let's go ahead and run this. And we should notice that our UI updates beautifully. And guys, we are getting this error here of publishing changes from a background thread. And we are going to go over how to solve that in the next video. Basically, it's the same problem as we were seeing here, where we needed to say dispatch queue.main.async in order to hop back on the main thread. And that's because back in our service, this automatically executes this task on a background thread when we say try, await, do, blah, 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 right? So we're going to be getting into that in the next video, how to introduce more in-depth error handling like we did down here. And overall, just how to do a full refactor from our completion handlers to this new async await functionality. But that is going to give you guys a really good idea and foundation of how async await works and why it's so much better than completion handlers. You guys notice we don't have any closures here. We can execute asynchronous code like fetching information from an API in a seemingly synchronous manner or sequential manner, right? In that I can use the data that I get back from that asynchronous process on the very next line of code. Handling errors is just a little bit different with these do and catch statements and these keywords with like async and throws. But overall, this is a much, much cleaner implementation. And we're going to be continuing on with that in the next video, guys. So get excited for that. We'll see you there. Peace. What's going on, guys? In this video, I want us to talk about the full pro version of the Swift Networking Masterclass and what features it's going to include over this free version that you have just finished up. So if you've already experienced the benefits of this free course, it's now time to supercharge your knowledge with the Swift Networking Masterclass Pro version. In the upgraded course, we're diving deeper into the intricacies of Swift networking, offering you an arsenal of advanced tools and techniques that will transform you into a networking master. So here's what you can expect from this premium upgrade. So we're going to be covering advanced Swift concurrency topics, guys. You're going to learn the latest with the Swift concurrency model to make your network requests even more responsive and efficient. And you're going to master async await and parallelism or concurrency to handle complex networking tasks seamlessly. We're also going to be introducing protocol-based generic services. So you're going to discover the power of protocol-oriented programming for creating reusable and versatile network service layers. You're going to design services that adapt to your app's evolving needs with ease. And then we're also going to cover dependency injections, guys. So you're going to understand how to manage dependencies effectively, creating a flexible and maintainable networking architecture, which is going to allow you to achieve cleaner code, improve testability, and effortless scalability. We're also going to cover caching data. So you're going to implement a robust caching mechanism to optimize performance and reduce network traffic, which ensures a smoother user experience by serving cached content intelligently. And then one of the major modules of the Pro upgrade, guys, is unit testing. We're going to explore the world of unit testing for our network-related code and view models. And you're going to build confidence in your app's functionality with comprehensive test coverage. And this is a big interview topic, guys. Almost every take-home interview that you get that involves any kind of networking functionality is going to ask you to implement unit tests, and we're going to go over how to do just that. We're also going to cover image loading and caching. So we're going to implement our own custom image view to elevate our app's multimedia experience by learning how to load and cache images efficiently. And we're going to improve user engagement with fast, responsive image handling and network optimization with image caching. And then overall, just more advanced networking architecture, guys. So you're going to gain insights into designing a scalable and maintainable networking architecture that meets the demands of real-world apps and navigate the complexities of large-scale app development with confidence. So all in all, guys, this is going to unlock new possibilities for you. Really take your app development skills to the next level, to that pro level, and it's going to help you ace those technical interviews that expect this kind of architecture in those apps. So with the Swift Networking Masterclass, you're not only going to expand your knowledge, but also empower yourself to create iOS apps that are faster, more reliable, more user-friendly, and testable than ever before. Whether you're building a social media platform, an e-commerce app, or any network-dependent application, or if you just want to improve your skills to help you get a job, this course is going to equip you with the expertise you need to stand out in the competitive app development landscape. Don't miss out on this, okay? It's an awesome and amazing opportunity. It's available on my website at stephancodes.com. The link is in the description, and it's this option you see right here, Swift Network Mastery. And guys, if you sign up and become a member on the website for just $39.99 a month, you get access to all courses and source code app templates. So that means you get access to all of these pro courses and all of these absolutely amazing app templates that I've built that will save you guys hundreds of hours of development. It takes me a long time to put these things together. And by becoming a member for just $39.99 a month, you guys can get access to all of this stuff. It's thousands of dollars worth of material for just $39.99 a month. So the value there is insane, guys. The price of that is going to go up soon. So make sure you get in at this $39.99 rate to take advantage of that amazing deal. But anyway, guys, thanks for watching this video. Hope to see you in the pro version of this course where we're going to cover all of those additional and amazing extra features. And thanks for watching this one, guys. We'll see you in the next one. Peace out.